You know what? I'm aching to start. Without further ado, without introduction, no with introduction. Welcome back to my participation in the Langjam Gamejam. Let's see, I'm actually going to control this volume a little bit more. Looks pretty high on your end. Let's see, how's my brain? I'll make it a little bit louder on your end, because it feels pretty unobtrusive, but okay. Creating a programming language and a game in 1 week. It is now day, whatever it is, 4 of my participation. 2, 3, 4, 5. I mean, it's the 5th day of the jam. It ends Saturday night for me. And, I currently... Oh. Well, currently my editor's broken. That's not the state that I left it in. But we are not super close. Yeah. Basically, I have a parser, and it can parse the code, and that's just about all it can do. And I was trying to basically make the internal format, so if we go to, like, test analysis... I was trying to make the intermediate format that would actually be run by the code, and I couldn't figure it out. I was getting completely lost in the complexity, so what I did off-stream was I basically, I said I wasn't going to write code. This is pseudocode, don't worry. But I'll show you basically what it looks like. Let's see if this actually, like, works in, if we set this to JavaScript. So, I wanted to get basically my entire code mapped out. I think it's basically I had to futz with it before I actually knew what I wanted. So I'll show you what it is. So for our player, that's the wrong thing. Well, basically good enough. This is the script, and this is the actual, like, entities table that we're going to have. Because yesterday I started working on, if we go to entities, we have a table here called entities. And what it's going to do is it has an entry that'll be called player for this type of entity. And basically all entities are designed under the assumption that there'll be multiple of them. But that doesn't make much sense for a player, but it could, so. That's our example so far. I could design it so it recognizes that the player would be more of a singleton, but I already have doubts that I'll be able to finish this, so that's fine. But there's one player after we allocate and create. And then the entity, like this table, keeps track of how many entities it should create and free in the given frame. So that way, like, we have the function to create them, it'll just increment that by 1, and then at the end of the frame or the start of the next frame, it'll allocate all of them, free all of them, you know, do some memory magic in a very efficient way, hopefully. And then there's several different phases of what I'm going to call compute. So, like, when the entity is created, we do these two objects. Oh, wait, I actually didn't, I'm imagining, like, a VM format. So basically, like, we'd have an instruction called VM call, and that would just take a pointer to this function, which is called platform file load sprite scalar. So this is the scalar version of the function because it just takes 1 argument. And we'd actually have this just be a constant. So this takes 1 argument, VM, constant. And I wanted my, like, VM format to be very simple, so it's going to be kind of a stack-based VM, where I just push arbitrary variables onto the stack with this constant, and then when we call a function, it just takes 1 argument off the stack and calls this function with that many arguments. And so the speed would just be a constant. Yeah, we'd actually have that up here as like this, for example. Oh wait, I should probably save this as, let's save this under repo concept art, probably like vm.js. So that way I just have syntax highlighting for my test. And so when we create, this function is called, or these variables will be initialized whenever we create an entity. And so when we run the toCreate function, it'll run this for like every single instance that's being created at once. So that does, we get the size of it. And so this is just a function with 0 arguments. And then we get the constant 2, and then we divide that. So basically this is this function. Because this is the only thing that's called at the creation of the entity. Everything else is either the creation of the class or run every frame. And so yeah, we just get the canvas size, divide it by 2. And we do this scalar because this is done for the entire, basically every single one of these positions every instance of player would start at the same position, this canvas size divided by 2. And then we'd have, for example, things that change every frame. So like the movement, this basically just gets the keyboard input, and then it turns it into an array of length 2. And then here, shockingly, we get local variables. So this is now this function. So yeah, we get our position, movement, speed, then we get our clamping. And so yeah, there's a lot of these different scalar and vector scalar functions. Basically all of these mean, for example, this. For example, we run our position, a vector of positions added to one value, which is movement divided by speed, because this is constant for all of the, or this is the same value for every instance of the player. So this whole VM is designed around the concept of this like batched computing, where every entity of the same type runs all of its code as like these destructive arrays whenever possible, or it'll automatically figure out that, for example, the movement would be the same for as many players as exist because there's only one keyboard, so we don't need to do this for every player. But we do need to do this for every player because basically this position can actually be initialized to a different value, or like that's the intention. I haven't implemented any of this yet. And then two more advanced things that I haven't implemented yet are variables that don't change every frame, but they change some frames, basically whenever they're like dependent variable changes. So this would be things like if an enemy is destroyed or something like that, there might be some signal that then updates a different variable. And messages are similar, except they are for things where like basically you are sending the value to an entity rather than it being dependent directly on some other variable. So kind of the same thing, but different enough that I would need to handle it differently. I have no idea how it'd work though. And then this is the actual values inside of our player. And basically, for these three, because these are global variables, or basically like, you know, as I said, variables where there's only one for all players, those would just be these would just be, you know, individual values. And then here, our position is a list of positions with just one entry right now. And then we have our events, and that basically is just some bytecode or some other like VM code. I don't know what exactly I'd call it. Though also these should be called the same thing here, because I think I'll just have the instructions like in this VM class. Just because there's so many just because the player class is so big. I should not have put all of the code in the same place, But oh well, what can I say? I'm dumb. But okay, and then we have external references. So any entity that refers to another entity, there's basically a bunch of complicated memory management stuff that we'll need to do. But basically, we can move entities in this like struct of arrays. So to keep track of them, there'll be an index. So like you get an index 0, and like maybe someday we create a new entity. So like this would turn to 1, which means that like, I guess it'd make more sense if we had like 1 and then like 1 here. And so like basically these point to indices inside the array. But yeah. Indices to indices. It'll be more clear once it actually starts existing in the game. But yeah, then I figured out, I was trying to imagine things like how to create them. As you see, it basically just increments that toCreate function, and then it adds like our referred, like our reference if we need it. So I guess this would be like false by default. Because yeah, basically this means we actually need a reference back to this specific entity somewhere else in the code. And then every frame, this is what I was trying to do yesterday, where basically for every type of entity, we get them. So we do our like freeing and creating, and we clear those. And then for every variable in our compute frame, we like update the variables in this order, and then we have like events that are added. So we queue messages for each event, and then otherwise we just apply those messages in some sort of loop. So I think what I'll do is I'm gonna kind of just grab this and I guess I'll just staple this back into here. So test analysis. What I should probably call this is something else, but I don't care that much actually. I'm gonna call this player.duet. Do we need any of this? Not really. This is a massive amount of code. But okay, I do think I should do like type duet, or what is it called? Type player. And I'm actually going to call this player there. Well, no, that's not quite right. What I'll do instead is I'm going to have this as let's not do that yet. What I want to do is I want to actually figure out, how do I test this? Where do we test this? I know what I'll do. Well, you know what? I actually do kind of need this. Okay. But instead, there's just going to be 0 entity. So what I'm going to be doing now is I'm going to be creating the empty version of this, which is almost the same, except for this list will be empty. And then instance variables are an array. And I think that means that, should I figure out where these instance variable, I think I'm trying to figure out if there's any instance where an allocation would not be a static variable at the same time, or like a global, quote-unquote. So globals are initialized to default values based on type. Instance variables are an empty array. Or let's say start as an empty array. And then let's have some constants here. Because we're going to have like constant 0. I think that means this expression doesn't need to be here anymore for now. Local 1, call 2, array 3. What are the instructions that we actually use in this? Constant call array local. Okay. I think call is going to be like the big thing. Basically, every single operation will just be calling a function on our platform. And eventually I'll make this correct as well. Actually, let's just remove this for now. That's an empty dictionary. But okay, is there anything here that isn't what I want? I did see that there are some, like, syntax errors, probably. Probably missing a comma or something like that. But okay, so like for a position here, we have no conditions. Okay, let's see what happens now. 507. $509. Not terribly difficult. 524. So yeah, let's just go through this, fix all of our bugs. $565. Missing comma. 654. Presumably missing comma, or missing semicolon, I guess. No, what is this for, actually? Ah, an extra bracket somehow. So what is this attached to? Huh. So somewhere in here, I'm doing too many indentations. Probably there. Wait, I don't get it. Yeah, because this instance here, like all of this stuff... Wait, no, none of this should exist here. Okay, well that explains why it was so long. Oh yeah, this feels a lot shorter than it was before, yeah. But okay, so when we get our analysis, this script would turn into this program. See, compute, allocation, sprite, blah, blah, blah. And then basically, if d type 0, type 1 equals f. And so I think what I'm actually going to do here is... Actually, where does this d... This is going to be actually just entities. Duet entities f. And so when we clear the this is going to be duet.entities equals nothing. Okay, and that means that we actually should allocate each entity when we do this. So we're going to do like or let type of duet.entities I'm going to call this here as well. A lot of like, yeah, I guess that's fine. And I'm not going to bother with that. Basically, we have several different maps. We have, well, actually, I can just not have that there, because I can just have that up here as, like, source. So yeah, the entity will just have the source of its file. So yeah, duet entities, we get the type name, we add it there, and then for let type in duet.entities, what we're going to do is we're also going to allocate that type. So that means when we do a run, oh wait, no. Let's do that up and run. So yeah, basically every single thing we run, and then what we'll do is duet program so I would actually call this d.type. Let's see, let's do let type name equal that. Basically what I'm doing right now is trying to make sure that the code knows what types are what. So like there should be one of these program entities, and basically this will automatically be created a single time. So we'll do duet allocate type, and then duet allocate, no, duet.create duet program. And we'll just create one of them. Okay, that seems like it's about correct. And then here we're just actually creating our events. So let's have that as like default events. Creation of the program and loading entity types. And then I will remove all of this stuff because these system initializers are no longer going to exist either. We will just create one program, allocate this, and then we start running the frame, which I'll remove that for now. Because, okay, let's make allocate. And actually, what I kind of want to do is, let allocations equal a list, and then what I'll do is all allocations, I think, will be, let's see. Let D equal, how do we get D dot keys? I'm trying to figure out how to do like a promise dot wait all here. So if we did like promise dot all, yeah, await promise all allocations. And the reason we need this is because a lot of the allocations will be doing things like loading sprites asynchronously, so I want to be able to do that before creating our thing. Well, actually, I think when we create the things, we can actually just, then we can await these, so we can do this a little, you know, have a little bit of asynchronicity. But okay. An allocation is also an async function, taking nothing. Well, actually, it needs to take a type. And it'd be like, if not type in duet.entities, we would then no such entity type turn false. Let E equal duet.entities type. Okay. And now what we do is basically what I had in here where we get this compute.allocation. So like, I guess it'd be for each allocation in duet compute allocation. We don't need this open. We don't need this open. For let alloc of e.compute allocation. And for now, I'm just going to do console log. Allocating this would be type dot alloc 0. Okay, let's see if that actually works. Platform is not defined. Oh, that makes sense. Analyze all duet.js 513. Fair enough. That's because all of these platform dot things need to be replaced with duet.platform. And then actually gonna be kind of miserable to figure out how to do this. Oh, but that also showed me that needs to be there. Okay, let's get a list of all of the variables that I actually need. File, load sprites. S. Because now functions will have a lot of variations. And we already have duet platform canvas size get, so I'll just do duet platform op vector divide by scalar scalar. there's such a mess of operations here, because basically, there's not only... I not only have to consider vectors of certain types, or like basically the fact that you can have arrays of variables that are applying to one variable. Oh, hi, it's going well. Let's see, trying to figure out. Yeah, let's put that there. Yeah, so we need divide S, and right now we just need a scalar. Ops, op v. Multiply scalar by scalars, add. So this is basically adding a vector of vectors to one vector, which I'm going to have as this, and basically it'll have like some sort of like reorder. So basically, like, a scalar vector and vector scalar are the same thing here. So we have, I guess, duet.clamp. I think this should also be under, like, op_v. So, like, a vector can be clamped to another vector. And we right now need a vector clamped, like a vector of vectors clamped to scalars of vectors. So like one vector each. Let's see, so, and we should probably also add subtract here. Because I think we do need it. Yeah, we need scalar subtraction. Oh, technically, yeah, these should be op_v. Oh, wait, no, these shouldn't be op_v. Okay. But yeah, we basically need almost the exact same things here. Op_s. Oh, wait. So these are operations between two scalars, and then there can be lists of scalars operating on values. Oh, geez. Are those the only things I need? I think they are. Then we need... Oh wait, we also need canvas. So this would be one sprite being drawn by a list of positions. Or being drawn several times on a list of positions. Okay. So now what I can do is I can go back up to platform. And I'll try to make this work. So yeah, we don't have op anymore. Well, we kind of do. I'll figure it out. Op scalar. Op vector. The difference between these... Oh yeah, and also here we don't have these division S, so there's no difference between these two. Clamp. Okay. So yeah, scalars. We'll have add, subtract, divide, or multiply, divide. And for now, I will try to figure out how to use my core thing here. And for now, I don't even need the type information, because that's not going to be read by the actual programs live. That's only for compiling them. So what we need here is, like, scalar, scalar, scalar vector, 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 reorder through. And technically we don't even need reorder, but that'll be good to remember at least. Okay, so when we're adding two numbers together, we're just going to return actually, I'm going to do function generate. So op gen op scalar vector, or like a vec b vector. I think this would be like type. Basically, I'm going to try to generate these operand things in a easier way. So, for example, when we reorder functions, we would have, like, opt gen. So we're generating operators, and that would be true. Actually, let's do opt core dot add through. I think that's fine. Okay. So basically, this will be how I like generate the code that I need for these. Multiply would be a multiply, which is regenerated, or which is like order independent, and then this is division. I think I can even do like bin gen. So basically, this generates variations on binary functions in a very simple way, where like let r equal this, return r. So for example, scalar scalar is equal to just that function. So basically this means that when we're adding two numbers together, we just call the function to add them. Scalar to vector is a function of a to b's, where basically for let I equal 0, I less than b's dot length, I plus plus, we would then do op a b's I, and actually let r equal this, r dot length equal b's length. We just allocate an array of that type, and then we're going to do return, or I guess this would be push this binary function. And we don't actually need these at all, because I'm going to just have that be a thing that we do. Well, yeah, that seems fine. Okay. And vector, vector, A's, B's. Oh, wait. We have commas here. And this is very similar, except for we read a different array. And we assume that these are all the same length. Oh, wait, no. This actually needs to be not pushed here. This would be I equals. And then what we can have is if reorder SV or r dot vector to scalar is the same as r dot vs, or scalar vector, else what we'd have is A's to B, where we do almost the exact same thing again, but instead we have A, and we would have B there. Okay, so is this correct? So this is a vector of A's to one scalar B. And so we create an array that's the same length as A, and we do this, and then we do that, and then we return. Okay. And actually, I do kind of want to, like, have function op... whatever. I'll keep that as it is. No, I actually do need that. Because now what I need is, for vector ops... No, you know what? I'll just do... No, I actually do need this. We need to have a function to generate all the bindings, and then we need a function to generate the function that's used in the bindings. Basically, we're creating a function here. Because now I need a separate thing, which is basically the exact same thing of, like... So we'd have op vs. Op. Okay. And then last but not least, almost the same thing as I said before, op bs. I'll put vector vector at the front. Okay. Okay, so that means that now, when we have, for example, add vector, so when we're adding a vector to another vector, bind gen op core, we would do an op vector vector op core add. basically a completely devious and dastardly thing. I am, like nesting this. So we're adding a list of lists of lists. Wait. Sub false subvector. And then we do like multiply and divide. And then we'd actually have 8 more functions because we would have one to add scalars to things. And that's basically just going to be this, but with an S here. And then we would have actually adding a scalar to a vector, which would then be the opposite. So admittedly, there is a lot of overlap between these functions right now, but I can't be bothered to figure out how to intelligently switch from one to the other. But this now means that I have a whole bunch of functions like platform.ops.add.ss, which would be like adding one number to another number. And then like VV would be adding a list of numbers to a list of numbers. And then like opv.vv would be adding a list of lists of numbers to another list of lists of numbers. And so that is now all of those functions taken care of. And so the only thing that I need now is drawing the sprite, which I could just generate another function here. So we could just have like a... I'm just going to do that here as like a... draw sprite is just equal to another bind gen. But this one's just a function that we have here of an image to a position with no reordering. So basically now we have the power to do all sorts of things. Now I should probably have some sort of type info here, but I don't care. Okay, so were those the only things that I needed? I needed file load sprite as well. Oh yeah, this is not bind gen, it's bin gen, because we're generating a binary operator. Because then we'd have a similar thing, function ungen op. So let r equal s op v, this would be a dot map op. Very brilliant. And so I can do the exact same thing for that when we do functions like this. Oh wait, though we need an async gen. Yeah, because now we'd have S and V here. I'll just keep it like that for now. We don't need to have, like, the opgen for everything. And then let's have this do the same thing, where we can have, well... yeah, let's have this. So we just have, like, because, yeah, we need 2 different types of clamp now. We need the op-v and op-s. clamp bingen. Wait, no, now we need some sort of arbitrary gen here. I guess I'll just do try gen. Which means that I would need then a whole bunch more functions. Because yeah, as you might imagine, it's getting complicated to figure out how to actually efficiently manage, like, being able to call functions with either, with like any of the parameters being arrays or single values. Because now we need scalar, 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 SSV, SVS, SVV, VSS, VSV, VVV, VVS, VVV. Ugh. Is there a better way of going about this that I can figure out? I guess just for simplicity, I only need the vector, vector, vector one. So I'm going to make a similar thing, or just a simple thing. Clamp. This will be like x, min, max. If x less than min, turn min. If x greater than max, turn max. Else, just return x. And so what I'll have here is basically just clamp. Clamp is just going to have three things. Scalar. So this would just be opcore clamp. Or it'll have scalar, vector, vector. No, vector, scalar, scalar. Or we actually now need that though. A is BC, so let r equal nothing, r dot length equals a's dot length. If for let I equals 0, I less than a's dot length, I plus plus, ri equals op a's I bc. Okay. And then we need basically the same thing except for A's, B's, and C's. Because we need this one for, oh wait, no, VSS. And then while we're here, like that. And then clamping here is almost exactly the same, except we actually have one layer deeper. Yeah, so this is not going to run very fast because I have like so many like nested function pointers of generating, like we're generating functions that take functions that take functions to get like, yeah, some nested mess. But now we basically have all of the functions that I think I need for the actual VM to like run temporarily. Okay, vs opv.add. Ah, because it's not opv.add anymore. Now it's opv.addv. Because we're adding two vectors together. And that means for the rest of these, that should be fine. VSS. Ah, and this is because opv, because we're clamping a vector. Try again. Canvas is not defined, and that's because 597. Oh. Can't access property 1. D.type is undefined. And that's because this one needs type.entity. No, type.program game. Source. So now I need to start making the game itself. So we'd have all this stuff set here. And then we'll have some allocation, and then we'll have some creation, and then we'll have no frame processing for the game at the moment. And are there any values? It'll be eventually my player. And then we'll have our events. And there will be no events. And no references, no free list. Okay. In promise, duet.create is not a function. Okay, so now what I want is to have, I guess it'd just be duet.platform.createS for now. And then we could do vector v as, oh wait, hang on. For now, we'll just return. We don't have that, actually. So yeah, we'll do duet.platform.create.s. Or I guess we'll just call it create.c. And ace, and this will actually just be type to count. Print, so console log print or creating, and this will be 1 by default. Instances of type. Hmm. And yeah, what that'll actually do is that'll do what I had here wherever I did that platform creation thing. Yeah, something like this. Let's just copy this. My rule for, like, creating these has kind of gone out the window. Or of, like, let's see, I'm gonna do refer equals false. What was I gonna say? My rule of not writing code off stream, because this pseudocode is literally just JavaScript. But okay. What I'm saying here is we are going to get the entities of this type, and then our count will, or the ID of this object will be the count plus the created count plus the, or minus the amount that we need to free next frame. And then we increment the number of counted ones like that. And actually that means that we should do, I guess this would be let start ID. So this is like the next number that's available. And then if we want to reference, ooh. Let's do if count equals 1. Else. So this will be start ID. Let's call this function getRef. If count equals 1, return get reference. Otherwise, let refs equal nothing, and then for let I equal 0, I less than count, I plus plus. We would do refs, oh wait, length equals count, I equals get ref. Okay. And this actually needs to be that because we do start ID and then we do start ID plus I. Okay. Basically, this gets us a reference to that thing, which right now we don't do anything with, but that could be useful. But okay, so if we do need a reference, if we only need one, we just call the function. Otherwise, we return a list of them, and then we are going to do start ID. And this doesn't actually run the function. But okay, that should do that. So hopefully now we can actually run our creation function. Okay, so we allocated. So we're allocating devices now. So creating one instance of game. So we're getting a little bit closer now. Canvas, draw sprite, FN single, multi, duet, blah, blah, blah. So yeah, now we don't need any of this frame stuff here. We just clear the screen, and then we add our frame here. Yeah, let's say, so this is going to be end the frame, begin the frame. And so yeah, let's basically do the exact same thing where I'm just going to copy the stuff from here, but we'd have, like, for example, we have a message queue. No messages. And then for every entity, we're going to do let type equal, let's just call this ent. So yeah, this is our entities table. And then if, or let's say we will remove some active entities, which would be type to free. And then I guess if that's less than 0, we'd have a bug, but for now, I don't need to worry about it. Well, can't hurt. Oh wait, no. We don't need that until we do if type.create. So we don't need this. Oh wait, no, we do need that. This is going to be duet.create. So now we actually do call a function called create, and that'd be t create. Well, do we do anything with this? I know what to do. For var or let val in it's going to be confusing to go back and forth between these. So this is going to be called type again. Yeah, because I'm literally getting these. Okay. So if we have any objects to create, what we're going to do is for each type in our type compute creation. These are things that will be done, like computed every single time that we run the creation function on entities. So we would do let start equal, let's let start idx. I think this is fine. So our starting index would be oh wait. Hang on. For computation, let val name equal val 0. And then we'll just console out. Let's just console log for now. Creating creation dot this. So this would be like type, I guess, type name dot val name. And so for now, I'll just say that. And then what we can do is we can actually just have type dot values val name dot length plus equals whatever it is. We're basically adding however many fields we need to that. Okay, that seems fine. So creation %d. So for now, these will be 1. Okay, so entity creation. We just do that. And then we set this back to 0. Okay. So we have our sprite that's being allocated. We're creating, quote unquote, one instance of game. And that has no fields for now, because now we need to go to game. And what that would be is when we call, so compute creation. My player. And that would do something like duet.call, I guess like VM constant 1. Actually, VM constant player. So we're going to create one player, and that would be done by VM call duet.platform.create_c with 2 arguments. Oh, actually 3. Because then we also need through. Because we need to get a reference to the player. And yeah, so very soon, my next step will be to actually make the thing that runs these instructions. Yeah, so now what we should be able to do is it should tell us that we're running the creation function, almost, val name. Oh. Can't access property length because type.values val name is null. What is val name? Creation. So value is my player, and that's because we should have a my player. Oh wait, no. This is done at allocation. My mistake, okay. There we go. So now, we're allocating... So we're creating one instance of game. Okay, we're allocating game my player. So now what we need to start doing is anytime we do this... So we should have actually had... Oh wait, I just realized. Of course we're not having anything creating. I was like, why isn't the player being created? This doesn't work yet. This doesn't exist yet. Because now what we actually need is to have something that can run this function. Which we started doing here, but this was terrible. So what I'm going to do instead is I'm going to have a little stack. So let's stack. And for now, we can just have the stack created every single time we invoke the eval function, which will surely be good. We'll basically just do eval alloc 1 here, which actually means that e.values var name equals eval that. Okay, and then we do our allocations there. Wait, but we don't do anything yet with the eval here. Right, we need some sort of, like, promises system of, like, anytime we call an async function, we actually need to add it to a list of promises. So I'll have a load sprite. This is now going to be async call, or like call async. And basically that's going to be promises is nothing. And then every frame will just wait for all of the promises to resolve. So yeah, I think what I'll do is I'll just have, that's fine here. So yeah, we're just going to allocate each of these. We don't need this, because now allocation does not actually do anything with this. And then duet.eval will now basically do, let's see, so we have type ID code, and that's going to be here, or let allocation of e.compute.allocation. I think I'll have it like this for now. And let's also call this type name. Okay. Basically, we know exactly which type we're running. Okay. So now, for let instruction actually, we need to match while a pointer, I know. Let pointer equal 0, pointer less than code. Dot length, pointer plus equals VM dot, well, let's say instruction. Okay. Basically, this is going to be kind of weird because we have to get the length of the instruction from the pointer because it's just a list of, it's just a loose list of values. But basically, if not instruction in VM console.error not an instruction, and this will be instruction turn 0. Oh, I see. That was supposed to be a semicolon. Oh wait, no, it wasn't. Wait, what? Oh, I see. Boom, right there. Okay, so basically what I'm doing here is VM length. Is this how we do the values here? Something like this. So a constant has like 2 instructions, a local has 2, calling has 3 because it's basically the instruction values I think that's fair. And this would also have 3, and this would have 2. Okay, so this is basically the instruction length. Okay. And that means that now what I can do is we can now start switching into each thing. So like, switch. What I'm going to do is instruction type stack pointer. Basically, just so I don't have such deep nesting here. Let's see. Let's do if stack dot length return stack pop. Basically, we just pop the last value from the stack, else return null. Okay. So we're going to have a function that just does one instruction per thing. And that would be by switching between the instructions. Case VM call, case VM constant, case VM call async, VM array. What other ones did we have? I think those are most of them. We don't have that many. Local. We need local vars as well. Okay. Okay, so now we'll have like default console error, not an instruction, and that would be instruction. Return false. Yeah, that's fair. Okay. Is this looping? I think I did this today already, right? I feel like sometimes the YouTube shuffling... Yeah, the YouTube shuffling just gets stuck between two songs. Okay. I've manually clicked on, like, one of the soundtrack... or one of the songs from Pseudo Regalia, but okay. So, a VM constant. All we do is we are going to stack push arg1. And then this would be... Oh, we actually need... oh wait, this actually isn't that bad at all. Basically, a local value does not get one value, it gets the entire list of values from the stack. So what we'd actually do is stack dot push entities type values arg1. And then when we call, we would do let arg count equal arg2, let function equal arg1, and we would pop two values from the stack. So that'd be args equal an empty array, args.length equal arg2. We actually don't need that there. And then we would do for so I'll have to make sure that this is what I want. I'll have to see how... Okay. So if we go back to the VM, basically now what I'm doing is whenever we call a function here, so let's say we call something with two values. So this is basically, we have a function called with 0 arguments. So we just get this value. Then we get a constant 2 on the stack. And then what we need to do is we need to pop so if we pop the constant, that's going to be at the end. Okay, so what I need to do actually is args.length -1 minus I. And so this will put it at the end of the array. And so that way, it's slightly more convenient for me to think about and reason about. Because otherwise I have to flip around the order of these, and that means that, for example, the subtraction would also need to be flipped. In order to do right minus left, you'd do left, right, minus, which too complicated for me. I don't know how, I would not be able to figure that out. Or I would not be able to remember that. And then for this, we do a very similar thing, except... Oh wait, no, hang on. Before we do that, we then do fn... let's do like stack.push. Ooh, we're gonna have to figure out how to actually set the promises to work quite right. Because we actually need to know the destination of the async call. Okay, well, I'll ignore that for now. What we would first do is we just stack, push the function result with the args, like that. And then for calling asynchronously, we would have promises, or duet promises push. And then we would, yeah, so here we would need to figure out what exactly we are getting back from this. And then when we do an array, all we would do is let fn, or let result equal nothing, result.length equals arg1, for let I equal 0, I less than arg's length, or result length, I++. Actually, what happens if we have an array that's like a equals nothing, and then we do a.length equals 15, or 14, then we do a. Okay, so it just has explicitly empty slots. Does that, like, allocate them properly? Because, okay, that makes sense. hopefully assigning the length actually sets things. And I think this would be the same thing where we actually just stack pop. And I'm sure I could do like a like slice the list and then swap it and then decrement, like reduce the length of the stack. But for now, this is fine. And then we'll just do stack.push result. So yeah, our real challenge will be getting duet promises. Let's actually get let promise equal that. And then we'll do duet.promises.push promise. And then stack push promise. So basically the stack will also have a reference to the promise, and then hopefully I can figure out where to get the value from that, because basically we will have our thing in here as like that. But okay, our VM is really simple, so hopefully that kind of works. Of let fn. So that is 369. Ah, because we need to have it here. Okay. Actually, I have a good idea. This is gonna look messy as hell. But okay. Hopefully that means that kind of works. Instruction is not defined. Oh, because we need, wait, huh? Where would that be? That'd be in 406. Because 406 no longer has the instruction. Not an instruction, undefined. Undefined, code pointer. So non-instruction 0, undefined 0, and that's because we have our pointer at, so instruction code pointer. Huh. Hang on. Okay, so pointer is 0. Oh, wait, hang on. It's because... let's skip that. This instruction function actually needs type stack code pointer, not just the type stacking pointer. Okay, now it's getting a little bit better. Oh, wait, hang on. But we can't have this here because, I know how to fix this. If not this in VM length, then we can have that there. Okay, reference error free list is not defined. So when we do a get ref, we are actually going to do et that. We're getting closer. Okay, promises is not defined. Creation, player position. We created one player position. Very powerful. That's exactly what we wanted. And then what we can actually do is creation. So let's let value equal value. So this is now going to be duet eval value 0, and then type dot values val name oh wait, the issue is when we create the node, we actually do only need to run this on a subset of the values, not all of them. I'll just, for now, to do only run on a subset of the values. Okay, so type values val name equals duet value. Let's say that. Okay, a little bit closer. 403. So our code should be an array. Okay, so our instruction is 0, and then we just push arg1, so that means that now the stack has the name player. Turn true, great. And then that equals that, and then pointer is 2, which is less than, not less than our length. Oh, right, because we actually add one more thing there. And then that means that now we have another instruction, which is a constant value, which should be... So what do we have? We have player 1 true. Okay. And that's because if we go back to this player, or if we go to the actual VM value, so if we go to game, we add a constant. So player 1 true, and then we're going to call create C with that. So that means that in the case of calling, we get the function. This function is our C. And then arg's length equals the number of args we have. And let's make sure those are in the correct order. We are creating one player and we need a reference to it. And so that means that we add that to the stack. So now we have the number 1. Why do we have the number 1? I probably should have checked what C was. Or I probably should have checked how that creation works, but I'll ignore that for now. Because yeah, right now we don't actually even need the reference to it. But okay, so we have gotten the value 1. And so that should mean that inside entities, inside our game, inside our values, my player is 1. Which, I mean, it should be 0 since there's only one player. But if we go to player, there should be one to create. So, okay, that runs properly. And that should mean that the allocation, so if we go to values here, our movement is nothing, our position is nothing. I mean, it should have been... Hang on. It should have gotten the speed and the thing here. I guess that's fair. Okay. Okay, so for let type and duet entities... So what are we doing now? We're evaling this code, which is to get... Okay, now we're doing it. We're getting our async function, and we should be getting... Oh, wait. Did something happen there? Type error. Can't process this. Length code is undefined. No, that's not quite where we are, is it? Is it because I'm playing with the code somewhere? So yeah, because we shouldn't fiddle with the code much. Or this code variable. Yeah, we only get it in here. Okay, so that should be fine. So yeah, there should be no possible way that the code changes ever. So we've done another instruction, and then we do our call. So yeah, this should be now running... Okay, so that should have worked just fine. And we have a value of 1 because we're calling the game there. And then our code should be this, so that means... Okay, and this looks correct. Basically, we have a constant of this path, and then we... Oh, but I think this assets should have a slash in front of it. So pointer equals code.length, code pointer, that, switch instruction. Wait, what was our instruction that we had? Why are we returning here? Oh, because we just did one instruction. Okay, so now our pointer is the next code, which should be... Okay, so this should be when we call or async call, yeah. So I think this is the place where we're having issues. So this should create a promise, state fulfilled, value image, okay. So yeah, we have that there. And then we add our promises to push there. So yeah, we return that there. Return true. And code is still code. Okay. So yeah, we get one stack there. Okay, so I think it's because our speed, then, is maybe going wrong. Okay. So that was all from creating one program, I guess? Oh wait, promise.all duet.promises, and that means that we have these promises here. And that means that I should, yeah, it'll be very important to figure out how to track where the promises are and replace them with the value that they have. Because, yeah, okay. So now next step. Ignore that. We got no messages. Refill that with black. So now that's all there. And then for, if we have any types to create, I like Godot. Yeah, I've been using it for a while. And I'd say it gets you about like 95% of the way there. And it's only if you're very particular about how you want things to work that you really have to worry about any of the fact that, like, people will say Godot is limited, and it is, but it's more like very advanced features like things like custom vertex attributes and things like that are much more difficult in Godot than like Unity, for example. So for like AA and AAA teams, something like Unity and Unreal still have more power, but Godot's okay. Okay, I see what's happening. Something is going wrong when I do our frame computations, I think, or what is our type? Our type is position. That's not correct. Eval. Oh, it's probably because... Yeah, okay. I'm literally just doing it wrong. We need to do type eval or val1. That's what I need. Admittedly, I think I still have the duet tag on right now, but that's a mistake because I'm working on a little game jam right now where we have to make our own programming language. But I do use Godot most of the time. So most of my streams are Godot. Where'd my mouse go? That was strange. Okay, let's see. Must be the canvas. Okay. So it's getting a little bit better. Op versus A's.length. Oh. Embarrassing. How could I do such a thing? I called it as a function. Silly me. Okay. So now the VM is actually running the code except for that pesky async function. And so what I might do is honestly just like halt the program and wait for it. So like halt program. Oh wait, no. Block and wait for promise. This would be so much easier if I just had a blocking thing. So the things that Unity has that Godot doesn't, it's pretty particular, but it's called vertex attributes. So like a 3D model can have things like color and texture coordinates and things like that. And in Unity you can add your own, which is often useful for things like more complicated shaders and like fancy visualizations. I've used them before. And in Godot, you're only limited to the texture coordinates, the light or the colors, the normals, and an extra set of texture coordinates specifically for baked lighting. In 2D games, I think Godot doesn't really add, or I think Unity doesn't have much of an edge over Godot. Like, Godot's quite even with Unity in terms of 2D games. But yeah, admittedly, I work almost entirely in 3D. But yeah, I think that's also why Godot is a lot more popular with 2D than 3D, just because it has a quite good 2D engine. And I think the 3D engine is fine for most games, but yeah, for more advanced things, then you would want, like, Unity or Unreal. But yeah, so long story short, 2D games, you can go ahead and use it. It's going to be good. But okay. Yeah. I guess we do, I know what to do. If duet promises.length, we need to do a whole big, so I am working on a programming language for the Langjam Gamejam. So our task was to make a programming language and a game using that language in 7 days. So my little language is here in the browser. And the main thing is it lets you set variables, and then you can have things change when the variable changes. So like this has its position all set up, and then whenever the position changes, it draws the sprite to the screen. And right now, I'm getting literally anything working. And I have about 3 days remaining. Well, 2 days until whatever I do. 2 days until I have to stop streaming because I'm not streaming Saturday, basically. And this jam ends Saturday night. But okay, my main problem now is that loading a file in JavaScript is async, which means that I have to figure out how to track all of my async requests. So it'll be like promises.all. And then we'll do duet.promises. In fact, we don't even need to do that there, because now what I need to do is I need to go through for let I can I check if a dictionary is empty? A.empty. Check if object is empty. I don't think that's even a thing that's possible. Yeah. I think what I'll have to do is basically... One. Stack.push this, and so that means we return true, and then if, so when we do an eval, what I need to do is, God. It's gonna be like vars, and Let's see. I'd say try to figure out what project you want to make, and then I really like the Game Maker's Toolkit's advice on tutorials, where basically he only looked up tutorials to do exactly what he wanted to do or exactly what he was stuck on, rather than starting from like, here's how to make a game tutorial, like style tutorials where you follow along for a long period. So yeah, he only looked up like the documentation for the game engine. And I would say that'd be an okay thing of like figuring out like looking up exactly like, okay, how do I create a sprite in Godot? How do I make the sprite move? Step-by-step things like that, where you direct what the steps are. And so that way you always feel like you're getting closer to what you want to make, rather than just following along like it's a lesson or a class, which can get pretty boring and like demoralizing. My poor brain is like not even grasping anything anymore though. Oh yeah, analyze doesn't do anything yet. Wait, where am I? Where'd all my code go? Oh, okay, it is all up here. Yeah, I'm in the code mines. I don't even I don't have the faintest idea what I'm doing. Yeah, I'm in like an extreme complexity thing. I actually completely forgot what I was even looking at. Man, I wish I could... Okay, there has to be a way in JavaScript to just block and wait. Well, actually... Okay, it should be okay. Basically, I was worried that every single value of every single array would have a promise in it, but I think what I can actually do is we can clear this, and then for each, or for, let type in duet entities. Or let's do this, t, and then let type equal duet entities t, for let v in type dot values. If type, so if then in type dot values v. Basically what I'm doing here is I'm detecting if it's a promise, which is basically if, well, all promises have a method called then, and I don't use methods called then. And so now what I can do is I can do type dot values v equals type dot values v dot value. Whew, okay. And then we clear the promises, so we have no promises anymore. Okay. Duet.promises.push is not a function because I changed this. I don't need to change this anymore. Unchange this. Yeah, admittedly, I've found LLMs don't really help unless it's like, basically like, if your question can't be answered by reading the first page of Google, it has no idea what it's doing. Maybe that changes if you have like a very sophisticated like agent LLM that's like running in the background constantly, but otherwise it doesn't really do anything. But okay, in promise type error can't convert undefined to object. That is because... Oh, right. Right-hand side of in should be an object. Got number. What is this? 448. If then in type.values v. I know. If type of type values v equals object, and there we go. Do I need this here anymore? And I don't need that anymore. Someday this will be cool, but okay. Can't access property my player type.value is undefined because I accidentally did type.value there. Okay, and now we can pause. And that should mean that eventually, oh, it's because I'm not doing events yet. So, okay. That means that now we are actually creating and allocating functions. Allocate and create objects. So our next step is to compute every value per frame. And that's going to be in our type. So it's going to be for... Oh, wait. Right. Entity creation, running in the frame. Do we need anything here? I'm going to do ent frame e type. Or let's say type. Basically, so that way I can have, like, much smaller things here. And then we'll just do duet ent frame type name. Because, yeah, it's getting so nested. In fact, that means I could just do duet.entities.map. Oh, wait, no. We shouldn't do that. Actually, we could do that. Oh, wait, no. No. That's not right. This is correct. Okay, so yeah, we create the entities. And then we will run for the entities. So this is going to be for let val of type compute frame. So every frame, each type has certain values that are updated. So for example, the player's position is updated every frame, and the player's movement as well. And so what I can do is we are going to let the val name equal 0. Actually, I think that'd be a good thing to separate out into a function. I'll figure it out later. Basically, this will all be almost exactly the same. So yeah, this entity creation right now isn't quite correct because it needs to only apply to entities that are new, not all of the entities. But for now, that'll be fine. And then every object that's updated every frame will also run its things here. And then we run type values, val name equals value. And then anything else that we needed to do here? Let's remove that. Let's go to our VM code. So yeah, because I have this here. Okay. And then what we can do is if fname and type.events, I will just copy this code. Oh wait, we actually need messages here. Hang on. Ignore this. Put this back exactly where it was. It barely helps anything anyway. Okay, and then if val name in type dot events basically, for example, the player has an event called position or on this variable, and that's what actually calls this. And so now what we can do is running in the frame, we can if condition in, or like, let's let event equal dot type dot events val name. And so I think an event just needs, oh wait, no, it does need a list of those. Okay, so that's going to be events, and then for event of events, if condition in event to do else. Actually, we can literally, well, I'll figure that out later. Basically, we're just going to do messages dot push event do. So basically, an event will actually have, actually, let's call it this. Type, type name, event.do. Actually, we can literally just set it like this. Okay. And then what we do is for let message of messages. We do that, and then messages equals nothing again. Oh, wait, no, we don't even bother with that. Wait, hang on. Ending the frame should have been after everything for the variable. What did I do? I changed something and I forgot what it was. Okay. That's basically correct as it was. Okay, for each message, we actually don't do that there, we do that up here. And then messages will equal nothing again. And then what we do is duet evaluate message 0, message 1. Okay, let's see if that's even correct. Okay, yeah. Basically, we get the type of the value for our message, and then we actually get the content of the message, which is this thing. Okay. And I also know how I'm going to do conditions, which will be basically let val equal duet.eval type name event condition. If not val, continue. Okay. Almost. 468 is wrong, though. Oh. Right, because we don't need this anymore, because... Wait, hang on. Wait, hang on, why is this here? Oh, I see. I'm smoking crack, basically. I have no idea what's happening. I've fucked up this code so much by, like, mangling things. Okay. So this was supposed to be for let type name in duet entities. Yeah, when I refactored my code all clever like, it was incorrect. Or I undid it properly. But okay, let's see if now it kind of works. Fn is not a function in the instruction. Let's cc equal duet.canvas.clearcolor.value. Why did it set it here? What does this mean? Duet.push fn value args. What is fn then? So that was in the frame. So what would be... Because we have a lot of things in here. So call this, divide this. Keyboard right get, keyboard left get. Okay, I know what it is. Okay. Basically, we have these things here. And so what I'm going to do is I'm actually just going to have another instruction called read. And so let's call it like global 1. Or let's say read 1. And that's going to be similar to that. Oh, wait, no. 5. vm.local. And so basically read will actually just do arg1.value. So when we did write get, these don't exist actually. So yeah, I'm just going to call those read. Okay, so does that work, kind of? Entities is not defined, and that's in instruction. So not an instruction, an object of type 1 value 0. Oh, wait, because now we don't have this. Yeah, because our read values don't have those. Okay, yeah. Args is not defined, and that's because, go to 394. Okay. Oh, wait, because this isn't a thing. Okay, so we were never actually running that thing yet. Entities is not defined in instruction 360. Stack.push duet entities type values blah. Can't access property values. Duet entities type is undefined. So what is our type here? Oh, because we're doing instruction wrong. It needs the type name, not the type that. Okay. And that's because we go to eval. Yeah, we're supposed to be using type name here. Okay. Okay, type error, can't access property values, duet entities type is undefined. Okay, so I'm going to call this type name. I'm going to make this consistent everywhere. And basically, if not type of type name equals... Oh wait, hang on, I just realized. We have modern technology for this. Okay. So that's because frame at 498 is doing it incorrectly. Yep. And that means that that should be fine. Okay. Whew, okay. We're getting a bit closer. So opvv is not working quite right. Okay, so what are our A's? We got 400, 300. Our B's are 0. Where is this coming from? What? Where's our stack trace? Call stack. Op SV. And that's because we're getting a scalar. So what is A here? Our B's are 0 and nan. Huh. And our instruction, what the heck is our instruction then? Our FN is op SV A and B. That shouldn't be the case anywhere. Because, first of all, op SV is supposed to return a function. Oh, I see, okay. Well, what's the op then? Our opvv. Okay, so what is the op here? Add A and B. So we're supposed to be adding A and B. A is 400 and 300, and B is 0, which is not correct. Hang on. Because we should be adding a vector of positions to a scalar of these things. And if we go to add v, we get a bind gen of vectors to add to true. Okay. Oh wait, I just realized the reason that reorder. I think I should just not have reorder here. Because I think it's just causing issues. Okay. So every time we do bin gen, we should just not have any of these vectors here, or any of these reorder functions. Okay, that was the issue, because reordering was invalid. It was, I'd forgotten how it would work. Okay. We're getting a little closer. So how do we check script check if object is function? Okay. So let's just do that. If type of fn is not equal to function, console error expected a function. Fn, and this would be code and pointer. Oh, and then we should probably return false here. Okay. Expected a function undefined, so that means we have function opvs, function get. So what is this undefined? So this is position movement speed. Okay. And that's because one of my functions, so function... Wait. Huh? Oh, okay, I see. This clamp VSS. Because it's not VSS, it's, okay, I see what I did. I typoed these. Okay, can't access property events. Valname.type is undefined. Why did I do that? Because this is supposed to be entities, Oh wait, this is supposed to be just type.events valname. Oh, okay. So now what I should do is I want to go to raw sprite. And what I'm going to do, what is our image? Our image is undefined. Why is our image undefined? Why are our positions nan? So it's not quite working so hot. Okay, so let's see the main thing first of all. So we got a promise. Its value is an image. Its type is an image. So that should be there. And then when we get the promise again, so for let t and duet.entities, let type equals this. For v and type values, then what I should do is, let's see, so we got a type of the player, type of, wait, what? Okay, this is correct. It's just out of order. So if type equals object, and object is then. Okay, so our sprite is a promise, and it should get a value here. Oh, it's because you can't get the result. Okay. So promises then returns a new promise that is immediately resolved after blah is resolved. In this case, the promise is that. I don't want that, though. I want to get the value of the promise. There is a way to access the promise's value directly after it has been resolved by using the following unsupported internal Node.js binding. God fucking damn it. How do I just get the value in the function? Can I just... I think what I need to do is I need to... What I should do... I know what I can do. Push promise. We should not push a promise. What we should actually push is push underscore promise duet promises dot length. And then what I can do is anytime this value has anything there, I know what to do. So promises should not be... Let's do promises as like waiting will be a list, and then results will be this. And so promises dot waiting push promise dot then so that'll be there. Promises dot result I equals value. So this is now a closure that gets the length of the promise, and then it sets it here. So that means that we can now do promises waiting dot length. Results equals that, and then we can also do here. Oh wait, no. Stack push promise ID. Okay, so any value that has promise in there, what we'll do is duet.promises.results let ID equal, hang on. Man, JavaScript knows how to make things that are like impossible to use. Like, why would a fulfilled promise not have the ability to just get the thing? But okay, let's say here print promise fulfilled. Oh, wait. Okay, let's try like type name dot v equals. Okay. Type values v. Argument of promise.all is not iterable, and that's because this needs to be waiting. Promises is not defined, and that's because, where is this? Promise.all is not iterable, promises is not defined at 392. Oh, I see. Duet.promises.resultsID.blah. Okay, getting a little closer. Oh, T. Actually, I have a good idea. So we can just do this. Wait, why is this at the start of the... Why is this here rather than at the start of the frame as well? Because what we should do is every frame, if we have promises that are waiting, we await those. So yeah, promises.all duet.blah. And that means that at the start of the frame... Okay, or basically... At the beginning of the frame, we do that. And then we have in our duet entities for each type name, we create the things, and then also we don't need this. We can just do for let v in type.values. Or let's go if promises... We'll just iterate over all of these for each of these. So this means that now we can have promises here. And then at the end of the frame is when we clear all of these promises. Okay. And I think what I should probably do is not have that here, but instead have that right before everything. So yeah, we'll do our promises, we'll get all of our things for the frames and stuff. Okay. Drove me insane. Okay. So now we have an image that can be drawn. We're not actually drawing the image, though, for some reason. Why aren't we drawing it? Is it because the debugger is running at, So this should be running. Okay, yeah. The only issue is that our position is nan. Why is that? Duet.player, or entities player. So if we go to values here, So our movement is 0 in nan. Our position is nan and nan and nan and nan. Movement. We should be reading... Okay, so what are we subtracting? We're subtracting 0 and 0. And what is that from? Okay, we're deep inside the belly of the code now. Oh wait, no, that's not the call stack here. Okay, eval frame. What is our evaluation here? Player, code, pointer. And that should be from here. Val name is movement. Okay. So for some reason, my array is what's causing issues here. So result equals that. Result length equals arg1. Plus plus. Result length minus 1I stack pop. Push results break. The big thing is that the stack should be popping here. But okay, so that's telling me that's why our thing is wrong there, which is good to know. Okay, so we got 0 minus 0. Great. And then we got undefined minus undefined, which is not as good. And that's because our stack is completely valid. Args is length 0. Okay, and that's... why is that there? So... oh... okay. My bad. Okay, so is it working a little bit better? Let's do raw sprite. Our positions are... now our positions are both nan. What? So subtracting 0 and 0. Is it because the... no, the array would be fine. Our positions, though... so yeah. Two big issues. One is the fact that this should still be... oh, this should be one position. Because, okay. Part of it is because... well, no, I have an idea. This needs to be just a scalar and vector. Okay, so that's part of that bug. The other part of the bug should be, I guess it must be vm.array. I feel like is the only other place that could be causing issues. Because yeah, we subtract 0 from 0. That makes sense. And then we get 0 as our result. So our length is 2. And then for that, we add a result which is 0. Then we add another result which is also 0. And then we get a result which is 0 and 0. Then we break. And then we return that value, which means that now our type, movement, val name equals value. Great. And then we should be getting our position, and this will also be important. So our code, we get our position, our movement, our speed. What is our position, actually? Okay, our position is just correct, yeah. Oh, wait, but hang on. Our position is supposed to be a vector that is like a length one. Hang on. Or values dot... Hang on, yeah. Okay. When we allocate a type name, hang on. So we call this, so, okay. That actually does need to be a vector of those. Well, no, hang on. This value needs to be like duplicated to every entity. Okay. I think what I can do for now is creation. So we'll just evaluate the value once. So it's going to be like for let val of this. We need to then so for let I equal 0, or let I equal let start equal that. Okay, so we only evaluate this value once. But we actually set it for every single one of these. So it's going to be type.values val name I equals start. No, wait, no. Equals init. So we just copy this value for every single copy of this. Which actually means that I should be copying it, How to clone an array. I'm pretty sure... Oh, easy. If array is array init val equals... Okay. So now we get the best, or now we get exactly what I want, which is basically, yeah, close all these. So yeah, part of that issue was the fact that the vector was being treated as just a list of numbers, not a list of vectors, or as being created as a list of numbers, when it expected a list of like 2D vectors for the position. Okay. Value is not defined. That's because we got that equals value, so we don't do that there. Okay, and now we do properly initialize the subset of values. Value is still not defined, and that's because we actually need now, okay, so now we have, for example, a sprite is that creation player.position. There should have been a list still. But we can see here it's 400, 300. Oh wait, no, but hang on. Is that because for lists of one value it doesn't actually do anything fancy? Let's just see if it actually does anything. So if we draw sprite. So what are our positions? Our position should be a list. It should have been a list of length 1. I don't know how that's not working still. Okay, let's skip this one. Okay. Basically, start equals values, value, position, length. Okay. Our initializer is that. And so we go from start to toCreate I++. So that should mean that values val name should now be position has a length. Okay, good. So position's an array of length 1, and it has this of 400 and 300. And then we log our creation there, sv. So that means, when we call drawSprite_sv, we should be getting the list of all of the positions. I guess now the big question is, so what is movement here? Movement 0, 0, that makes sense. And currently, our position should be a list. Okay. Type values val name equals value. Wait, hang on. Okay, I see a problem here. This was supposed to also be an array of length 1. So there's something wrong with my position code. Basically every frame. How would this be causing issues? Where is the malfunction? Basically, we get our movement and we get our speed, and we multiply those by 2 as a list of lists. Or we get the movement, yeah, We get 1 movement, 1 speed. And then what I'm going to do is scalar vector. So that means that we add 1 movement vector, one of like this result vector, to this position vector. Or a list of these. Which means we should have op sv Okay, so we don't need to go through creation anymore. Where's my mouse going anyway? Okay, so our operation is vector vector. That makes sense. What are our A's? So our A is movement, and our B is a list containing not the things it's supposed to contain. It's supposed to be a list of positions, not like 1 position. So where is that happening at? That would be VM local. So somehow at VM local, by the time we get to here, the value's already wrong. Okay, so for example, if we go to our stack... Oh wait, no, not our stack. If we go to the code here... What is our return value? Return is movement. Okay, so we have our movement. And then I guess we just keep going. Get this, which is pointer 1, which should return the... Okay, that returns speed. Good. And those are looking correct. Go to values position. So yeah, this is a... We can see the list. Is it because push will, like, undo what I'm looking for? But okay, our return value here is position. And then when we add to the stack here, okay, we have the list of values here. So somehow, by the time we get to the call function, it's already wrong. Because yeah, this function is basically, we're getting a single value and then we're adding a vector of values to it. Which is basically our speed, and then we're adding a bunch of positions to the speed. So that means somehow, I think stack.pop doesn't handle arrays correctly. What's our args now? No, look at that. It works just fine there. So we got A's and B's. Okay, our B is a link. Okay. Okay. That is correct. So our return value should be this. Okay, so it's still at the same position. And then we return R. And that means that we have that there. And then we break. And then we have all this crap. Okay, and then that should mean that once we get to, I guess let's go to entities again. So entities, player, values. So position should still be a list of length 1. Okay, so that's still correct. So what is our function? Our function's get. Okay, so let's continue until we get to draw sprite again. Because our positions is still not right. It's still not right. Why is it still not right? It's right here. It's correct in here. Because, yeah, we have our image. And then we have our vector, which contains this. And then somehow... So draw sprite SV. So somehow when we call the function, does ... do something weird? Like, hang on. Let's do like a equals, or let arg equal, hello world. Let's make a nested array of like world and then 1. Let's keep that short like that. Basically, I'm adding a little thing here. So now we have an array that contains an array. So if I did a console.log ... arg. No? Okay, so that works how I expect it to. So why is our arguments here are correct, but then when we get into this, is it correct? Okay, I must be going insane. I think it is correct. Okay, I think I just am losing my mind and don't know what I'm looking at. And also my mouse keeps disappearing. It's insane. It's horrible. Okay, the big problem is still the fact that if we go to values, position, I mean, it should be drawing to the right place. Let's just print... Yeah, the big issue is for some reason the image just isn't drawing. Is it because this is happening? Because, yeah, we have that happening. So we should have a sprite in here. So what I'm going to do is canvas. Let's do constant, no. I'm just going to do a constant 0, 0. Because, yeah, for some reason now the issue is simply the fact that the image doesn't exist. Like, there should be a sprite that's being drawn to the thing here. Is it because the... Let's draw rectangle. Let's remove this for now. It might be that I'm just clearing the canvas at the wrong place. And actually, we don't even need that because that's just in here. Is there anywhere else where this would be happening? Yeah, because the big thing is this isn't correct. Like, first of all, why is it black? It's not supposed to be black. Because now we're not actually clearing the image. Am I like editing the wrong code? What's happening here? So like, when exactly does it turn black? So like, we create our things, we do our entities, we do our computation here, we await our promises, which is great. Is it because the promises are not... No, we fulfill our promises properly. And then if we get our creation here, great, great, great. I think what I should do is... I think what happens is we draw the wrong... No, that should be fine. Because yeah, we don't do that any time again. Because we always get the sprites at the allocation phase. Val name movement value is that. Duet value type name blah. New movement type equals this. Position... Okay, so we don't need to deal with any of this stuff. Well, okay, I guess I gotta figure out this. Okay. So for some reason, drawing the player sprite is what has messed up our thing. So yeah, this sprite is just a gigantic black box. But why? Hang on, let's go to entities. Duet.entities.player .values. Okay. So our sprite is a blob of local stuff. And what is its width? What is its height? Natural width, natural height. Width and height are 32. So yeah, we have a 32 by 16 sprite, and anytime we draw image, it completely makes the canvas black. So let's draw image makes canvas black. If you're using this somewhere in your code, use this instead. What? Okay, so how about some code and references? Check your syntax. It's supposed to be draw image background. Okay. Width. Oh, I'm stupid. Okay, hang on. Close that. Okay, so our image is this, and its width and height, or width is 16, our height is 32. Draw image, So we should be able to just do dx and dy, actually. Width, height. So load sprite document.create image blob. So create object URL. Let's see if there's a better way to do JS load image. Let's go back to school. So image equals new image. Image.url equals that. Image on load equals that. So that's not really what I want. I want, can I await an image on load? But we have this. So URL equals URL create object blah, create object URL append child. Image source equals URL. Do I need to create an image here instead? No, this doesn't matter. Like, this would be fine, and then we just do, like, image source equals that. So let's start by creating the image. Well, we can just do that in between these two. So yeah, we await a fetch of the path. And yeah, if it's not okay, we return null. Otherwise, we get the image, or we create a new image. We set its source to this. So I'm going to say JS load image for canvas. Maybe there's something different that I'm not doing. Draw image should be draw image, get element by ID. So is there any difference between get or new image and document create thing? I bet you it's because this needs a slash there. I did mention that like 16,000 years ago. Okay. Still not working. Even though the image has been loaded, there's an image source, there's all this stuff. I don't understand, because it knows all the dimensions of it, so there shouldn't be anything wrong with it. So what's our canvas size? Is our canvas? No, our canvas is just a normal thing. 600 by 800, or 800 by 600, however we want to name it. Let's see if that's working. Data URL. I know that that exists. URL. Oh, it's create object URL. Is it because I need to do, Document onload. Can we do like JS await document onload? So it's not that, it's a callback. Okay, so I'm going to try this, where we return resolve, reject, and then we'll set our image to be this. Image source equals path. Oh, wait, no, image onload equals resolve with image. Okay. And then we don't need any of this because now we're just returning a new promise. And that means we don't actually need this to be async here. Oh, and this should be B. File.load sprite like that. Okay, so our image, now our image actually exists as a thing. And it still doesn't work. It's gotta be something to do with just what I'm calling it with. Like, are my positions undefined or something? Hang on, what are my positions? So we have... Wait, no. I'm misunderstanding this. Okay, we have an array of length 1, and then we get position here. So position should be a thing that is valid. Hang on, let's try this again. So yeah, position is 400 and 300. So we're putting this image at 400 and 300 with its width, which is 16 and a height 32. I cannot possibly understand why this isn't working anymore, because I made a thing where it would work. But okay, so now we can load an image just fine. Because, yeah, now the image also has, like, the correct path rather than an object path, so that's not an issue now. And also considering the fact that this worked yesterday with the same code, just in a different organization. Oh, canvas.createImage, canvas.draw image. I'm slurring my words now, which isn't a new thing, but... I don't think this is going to be correct. If it has like 7,000 pages of preamble, it's just AI generated. It's just garbage. So we should have a resolve now. And you know what? We don't really need a scaler there because we're just gonna do, we're just gonna wait for all of them. So, because all node equals start, on error equals function blah. Source equals this, start equals that. So yeah, we're guaranteed, I think, let's print, so loaded, path. So yeah, that happened a while ago. And then it just turns black. Just turns the whole screen black. Yeah, let's print again. Why can I not just reload? Oh yeah, because the canvas takes over the button. Then let's pause. So yeah, we can see. I don't like that, like, I have so much work that I need to still do on this project, and I'm being completely blocked by the fact that I cannot draw an image using the draw image function. Am I getting the wrong content? Is it like is it like an uppercase 2 or D there? So when we get the context here, where's our context created at? Do we need to create a new context? Maybe we do like duet.draw. Let's do like duet.draw2D equals that, and then when we get the canvas equals okay. I was not assigning. Wait, no. This is wait, no, that's completely irrelevant. Yeah, because we set that there. That's perfectly fine. Maybe we have to create no, so we don't need this there. I'm gonna have this as like run up here. Our draw 2D will be get context 2D. So are they doing something different with their... Canvas rendering context 2D, so let's figure out, okay, where that comes from. So canvas get context 2D, get element by ID source, load E, CTX draw image. So they have like 17 quadrillion little fields there. How does this work? What are they doing there? Okay, I see. image onload equals draw image actual size. Actually, wait, why is this async now? Now this doesn't need to be async at all. And it's only the frame that's async. Uncaught reference image canvas is not defined. Where are we doing canvas now? Wait, what's happening now? 445? Oh, I see. I feel like this is the best hope. So 80% it loads right, but 20% I have a black canvas instead of my image. This is BGBU, but not sure. Just draw image background width height 0, 0. Is this supposed to be... Yeah. Okay, so 0, 0 width height. I still don't know what to data URL is. How do I get to the like actual reference for this thing? Returns a data URL containing a representation of the image in the format specified by the type parameter. Defaults to PNG. Returned image is a resolution of 96 dpi. Gets the drawing context, or if the context identifier is not supported. Or the canvas has already been set with a different context mode. So how do we... Do we have to set the context? Maybe that's what I'm doing wrong? So like syntax. So this method returns a drawing context of the canvas or null. Later calls to this method on the same canvas element with the same context type will always return the same drawing context. Okay, so it's not possible to get a different drawing context on a given canvas element. Okay, so that should be correct. It shouldn't be that there's some error with this. And it's 2D with a lowercase d. I'm still so... I guess I'm just utterly lost. I'm just completely, like, defeated. It's like, how could, after all of the, like, complexity of this, the thing that defeats me is the fact that draw image does not draw the image. Ugh. Like, are there any errors that can happen with this? You know, I'm just gonna add a let's just append it. Okay, so what's the error now? DOM exception cannot have more than one element child of a document. Can we do document.append? DOM exception cannot have more than one element child of a document. Let's do editor. Editor.append is not a function. That's because... I need to do something with our things here. Oh, no, editor. Editor append child is not a function. Oh, right, because we need, okay, because that doesn't actually have the object here. I'm just gonna append it to, get element by ID. Let's just have a fucking div that has loaded images. It's just gonna be like, here, in the files, actually. Div ID equals loaded images. Okay. It's there. It exists. It exists in the game. And it's not working. Is it because... Let's just go to Edge. Let's see if it's some sort of browser incompatibility. Oh my fucking god. It's just Firefox just not working. What is the meaning of this? Is it fucking uBlock? Like, I'm on the verge of killing myself over here. Committing suicide live on stream, and it turns out it's just Firefox isn't fucking working. It's just... How does the draw... Like, what am I doing that's not, like, compatible? But okay. Now I can do my clear color. Let draw 2D equal canvas.convex set. Oh, we don't need that. We just do duet draw 2D. Fill style equals this. This equals that. Actually, we don't even need this. Because we just set the clear color. Oh, wait, no. We do have to do this because the canvas clear color, like, we might fill with a different rectangle. Okay. Okay. What's happening in our console? In promise, our canvas is not defined at frame. Oh, right. Because this needs to be duet canvas. There we are. Okay, and I'm also gonna set the delta ms to 16 or something. Wait, what does that mean? Oh, okay, I see. It basically, I'm allowed to go all the way over here. So I think what I'm going to do is actually draw sprite. I'm going to draw the sprites at the center of themselves. So let's do center equal, so this will be like, okay. I am like overwhelmed still that it just didn't work. It just for no reason. It didn't work. Editor set content. Wait, what? No, that's fine. Wait, what? Huh? Okay, it just didn't work for a frame there. Okay, I hate browsers so much. I hate browsers. Infinite suffering for all browsers. I'm gonna puke. I'm gonna puke from rage. But okay, I have one thing. Okay. Also, I kind of want, I'm gonna change this to be input instead of WASD. Because I'm just gonna have, like, W. Let's make sure that that works. Basically, I'm gonna have WASD and, no, and that's gonna make me want to die. You get error keys and you'll like it. And then you use the mouse to aim it. And that'll be my next step. Can we draw a rotated, Oh, wait, no. I need to set this as my default page. I'm still, like, traumatized. That how long did I spend trying to figure that fucking draw image out? Like, an hour? And the answer was literally nothing changed from when I was using Firefox. Firefox just decided to stop working. Okay. I don't need to look up anything, because now what I need to do is I need to go through the process of learning how to make this work. So, or converting my parse tree into this program. No wonder I can't sleep very well after every one of these streams. I've been like, wondering like why on earth, do I have such bad sleep after every single one of these streams, even though I only end at like 8 p.m. at the latest. Okay. Should we do messages at the start of a thing? I don't care. The start of a frame and the end of the previous frame are the same thing. What I'm going to do is I'm just going to start trying to understand my parse tree. So now we need the actual function analyze. We're going to let entity equal yeah, I mean, I explained to someone else, basically, it feels like AI is only really good at reading the first page of Google results and then summarizing it half correctly. Because basically, anytime I've been stuck on something and asked AI, it was also wrong. So yeah, basically anything that's, like, complicated. But it's good for, like, if you are, like, doing scripting in something and you don't want to bother, like, learning all the weird nuances of that particular scripting, but it's not particularly complicated. Though actually, you know what? That's kind of exactly what I'm doing here. So what I'm going to say is let's ask Bing Chilling. Because that is literally, let's say, why does this function only work on Edge and not Firefox? Image waiting for onload and position or positions is a list of let's say positions is a list of pairs of coordinates and duet draw 2D is a 2D context from a canvas. On Firefox, this makes the entire canvas black. Let's see. So Firefox is turning your canvas black because the image you're drawing violates its security rules. That's fucking dumb. So it's detecting a tainted canvas. The image comes from another domain, or from an image, or from a data URL without a proper CORS, or from a blob with the file rights, or from a canvas that was already tainted earlier. I don't think that's the issue. Hang on. Because I'm pretty sure... Wait, hang on. I love Windows and how when I type Windows key and FI, it goes to the private browsing automatically. But okay, because if we go to here, there's no warnings. Yeah, we don't see any warnings for security issues. Okay, I'm going to see if this works properly. So if we go to image source equals blah. No. Yeah. So yeah, this isn't the answer, but let's check the other possibilities. So using an off-screen canvas, we're not doing that. The image has 0 width and height. No, that wasn't true because I was logging this here. I guess I can log image.complete. So let's do image height, image complete. So pause that. So yeah, we have width, height, complete. So what is image.decode? Drawing before the image is fully decoded. How would we check that? Yeah, so it seems like it has not answered it, basically. Unless it's something to do with decoding the image, which I guess is possible, but it's a 16 by 32 pixel PNG. So yeah, I'll assume that I have to ask a smarter AI. No, I haven't. Okay, what I'm going to do is I'm going to just mark it as a bug. Because what's strange especially to me is the fact that I could load the image before and draw it just fine when I did this yesterday. I might even have to review my thing. So like, cannot draw images. It's especially strange to me that it said this is a classic issue when I didn't see any search results about that. But okay, let's go back to test analysis. So basically, every entity will have a lot of things. Source, file. Wait, hang on. Let file equal duet files file name. Okay, so our source will be the file name. Count 0. To create 0. To free 0. Compute. Okay, so as we parse the file, we will return an entity. And so a tree should be pretty simple to parse because we ignore things like comments. So that means that the first object in the tree should be the header. So yeah, let's go to... Oh wait, no. Yeah, we no longer use Firefox. Firefoxes are bad. Our enemy. Alright. So I'm just going to kind of like go through this step by step. Figure out like what exactly is our tree here. Not quite as fast. Length 2, start 2. Okay. So let header equals tree children 0 if header.type is not equal to parse node.header. Let's add errors to these. Or let's do let's do that. So basically, this is now going to be test analyze 0. So this is like result. So let e equal result 0. Let errors equal result 1. For let e in errors, or let e of errors. Console.log for errors. And that means we can actually have the errors. We're just going to do errors.push message. I know what to do. So function error message. Almost. I have the like bytecode internal representation, which for some godforsaken reason only works on Edge, not Firefox. Because Firefox, for some reason, draw image will just turn the entire canvas black. You know, that's fine. Yeah, I'm about to have a heart attack. I was literally, like, on the verge of tears for, like, an hour trying to figure it out, and the answer was to just switch to Edge and figure it out later. Because, yeah, there's, like, no log whatsoever about it as well. Okay, so we're going to do error expected the program to start with a header. Oh. And actually, this means go parse results. What I actually want to do here is for each error, I'm going to just print the errors here. So like log yeah, it's such an inexplicable error as well, because I was loading the image and then like working with it just fine before, and now it just doesn't work. Like, because I can put the image on the screen as like as part of the document, but it just doesn't work as part of the canvas, and I cannot figure out why. Errors. Let's do... Oh wait, we should get... I know what I could do here. I could just do start and length, because that is exactly what the canvas has. And then we can have, I guess, tokens here. Okay. So we'd have result.errors, tokens. And I'm just going to do the exact same thing for the rest of this. Oh, wait. I'm fine with that not being there. Okay, so duet.analyze f. What we're actually going to do here is we're going to have result 1. Actually, let's just have... This is going to be result.entity. This is going to be result.errors. And then we don't even need this because we're just going to do that. And then we're going to do duet files f tokens. I'm not going to spend like an hour installing an AI agent to figure out what the issue is. I feel like a lot of the time chatters will just say like, oh, you should do this thing. It's really easy. And literally every time it takes like 2.5 hours and then it doesn't work. Like, it's a very common pattern. But okay, let's see. So we need to go back to analyze. And what I'm going to do here is I'm just going to make this an object. So it's so it's sane. And admittedly, it especially won't help because I've been streaming for 4 hours and I'm already kind of like, I'm slurring my words already. I don't think I'm ready to install software. Okay, good. It actually tells me that this is an issue. There we are. Cannot read properties of undefined. Reading 1. Analyze all. That's at 768. Ah, I see. Because we're not actually setting things properly. So now we actually start doing our header stuff. So when we do TK text, I need to figure out... I'll just duplicate this. And that means I also need to get this again. Low text equals duet files file name dot text to lowercase. And we need a token here. So this is going to be low text substring token start token length let's do what? Parse node names. Yeah, it's public. Let's see. That'd be fun. Git hum com needle full. So it'll be, where would it be? Where's my repositories? Have I pushed the newest changes? I will push them. Oh, I already have. Okay. Yeah, I'll let you see if there's anything that it'll actually figure out. Because yeah, it does seem like if Firefox just can't render to canvas, that'd be a thing that's like documented by something. So I would assume an AI agent could figure out why that's happening. It just did not when I asked it. But okay, so we get an entity, and then what I'm going to do is let's do, actually we can do that. That'll be all fine. So let name equal I guess tk text. Let's get tokens. Tokens header start. No, let type equal that. Let name equal tk text tokens header dot start. I guess header. I mean, technically this should just be +1. If type not equal to, let's say if not type in type. Oh wait, and that means actually header dot start, header dot length. Okay. So maybe it's something to do specifically with add-ons that I have, like AdBlock, Privacy Badger? Maybe Privacy Badger, actually. Maybe it detects this thing here. Because maybe it's detecting the image as a thing to be causing issues. Why did that not work? Oh, local lost. No trackers, so we'll disable this for the site. We trusted this for the site. Turn this off. Oh yeah, but now it's actually not going to do anything because the we're not doing the test analysis. So yeah, basically what it should be is this to do the testing. Which will be a while. Yeah. So expected the program type, or expected the script type to be program or entity. And this would be header start 1. Or okay. And so what this means is now... Oh wait, also, if name in duet entities error name already exists. Oh wait, and hang on. Found type. Okay. Script or entity class type or name already exists, and this will start from header start +1 1. Otherwise, entity type this will equal type name. So that should at least get us the type of the object. Object C, object run, object compile and run as run. So et.count. So count should be 0 here, so this should be fine. So what is our et here? So what are our entities? So we have an undefined value. Okay, so we can skip the test analysis for the time being. So result is result entity, result errors, type name equals d.type1. So that means we should have this. So what is our beautiful result here? So its type is somehow empty. What are our errors, actually? We have no errors. Is it because I just haven't set this properly? No, that seems fine. So this should be called... Oh... I'm forgetting how to do things. I'm getting to that point where I'm, like, not reading my code properly. Okay, so now it should have things there, hopefully. Substring is not a function, that's fair, because it's actually with an R. Okay. So that's working now. And then what I can do is et is equal to this thing, which has our type, all that beautiful stuff. Beautiful, and then it does nothing because we have nothing that's actually running right now. And that means we'll need a few things for our, for more advanced compilation. So it'd be like let globals equal this, let constants equal, well, actually, let's say this. So each variable, actually, let's just have this, and basically a variable will have a few things. It'll have a type, which is just an actual type. Actually, let's do this. It'll have its update. Oh, wait, hang on. And then I think we still need a storage of storage. And so this can be basically real, int, array, etc. Update will be once frame message var. I guess like listener. And storage would be global or instance. And then we would also have dependencies as just an array of strings. And then probably all of our compute for each of these. Well, no, we would do that later. But okay, the real thing that I'll need to determine now is, do we have bindings for all of these? Because now what we're going to do is, for each token in the thing, I equals 0, I is less than 3, no, I is going to be equal to 1, I is less than tree.children length, I plus plus. So basically, I'm just going to log for now. Let's do duet.parseNodeName. Or let's say, let this node equal tree children I. So basically, we'll just go through all of the top level nodes in the parse tree. And then this would be node type. And then that should be, okay, they're all bindings. And one event. That sounds good. If node type is equal to binding, if, or else if node.type is equal to duet.parseNode.events, else error unexpected statement type duet parse node names node type, and this would be the node start node length. Thankfully, this code is not terribly complicated. Well, thankfully the code is structured in a very simple way, where it should be quite easy to get the variables that we have, and then what I'll need to do is put all those variables together properly. Which may need an extra step for like global things, but for now, I'm treating all the variables as if they're local. So let v equal, so we need to get the first node of this thing. Binding, and then we do just node. Okay. And thankfully, everything has pretty predictable structures, because this has a declaration of independence. And then that has either an identifier or something like that. Okay, so let name equal, or let identifier equal tree.children. Oh wait, no. Node children 0. Let value equal node children 1. And then what we would do is oh no, this is declaration. Don't I have like read tree? How does read tree look? Okay. So what I kind of want is I want this parse, like print parse tree. Let's do that. Oh wait, we don't need that. Or let's say printable tree. Okay, and now what I can do is when we analyze, I want to get the printable parse tree. Our printable tree declaration. Value. Interesting. Oh, wait, because this actually needs a few things. It needs... Our tokens. Or it needs basically f, which is going to be a file. Okay, yeah. And then what I can do is the next time we have printable tree, we'll just get this file here as well, because that'd be, yeah, file. Well, I want to be able to figure out, like, how exactly this all works. So, like, what is happening here? So, f... So, tree.children.length. Type is this. So we get the tree. Okay. So what is our tree here? Our tree has a type of this. Our tree has children of that. So, why would it be not working? Is it because this map doesn't work? Parse node name 0 blah 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 blah. And then tree.type. But tree has a type here. It has that. And so duet.parse node names here, it should be able to get that this is a declaration, because it literally, we have tree, and then we have dot type, but why is tree? Oh, because it's a 0. Wait, why is it a 0, though? Oh, because I'm an idiot. Yeah. My brain's falling out of my head. So that was all that was going wrong there. Because, yeah, I just want a little bit more help from this poor little thing, trying to figure out all that I'm doing. Huh. So why is that undefined? Because we can see here that once we get one level deeper... Oh, I know exactly why. There we go. Okay. So yeah, here I'll probably just not even bother with that for the time being. Basically, I was setting the canvas clear color through this script, but right now the parser would have to then or the analyzer would have to figure out that that is not a variable that is assigned to it, which I don't even have the system for yet. So what I'm going to do instead is just have I'm just going to worry about the actual, like, local variables first. So if we've gotten this far, we should be able to assume that, like, the function is broadly correct. So yeah, if we got a binding, for now we'll do that. And then, for example, we would do... let name equal children 0 if name type not equal to parse node accessor. What I'll do right now is warn not so functions not implemented yet, or I guess advanced bindings. Or name.length, no. Or name.type length greater than 1. Let's say that. So basically any sort of like this dot that would be too complicated for me at the moment. Maybe tomorrow. So yeah, otherwise we can do else let actually we'll just do let name equal, or like let so this will be like idents. TK text ident start. So basically, now what we're going to do is we're going to get this text here. And we're just going to set the variables name equal to, actually, let's do if variables in name, or if name in variables. Then what we can do is error duplicate name, or duplicate variable. And that would be name. And the start would be ident start 1. Variables.name would equal type undefined. Or you know what? What else did we need here? Basically, update equals update dot once storage global. Basically, the way that variables work is they're assumed to be global until something proves that wrong. So basically, it's assumed that there's only going to be one of them. Yeah, until all of this happens. So let's make sure that like update has all these things. Okay, so constant variable frame. I prefer having but oh well, const storage. So this will be global 1, no 0. And then instance 1. And we actually need message like that. And we'll have to start developing the code for these, but that'll be... I guess we could probably have some... Yeah, I guess each of these would have also a compute that would be like preliminary, so just be like let's just have this be nothing for now. So this would be a dictionary, string, pre-formatted bytecode. And I'll have to figure out what the actual pre-formatted code is, basically. Because we only know what the final code will look like once we've determined all the dependencies of all the variables. We also need that for, like, the order in which the variables are, like, sorted. So I guess we'd also have, like, order. Well, nah, that'd be fine. So yeah, we create our variable here. Let's make sure that that works. Because yeah, for each variable, we would create a value in the thing. So let's do that. Entities, because that's entity. Okay. So now if we did duet dot files, duet game dot duet dot analysis, or no. If we go to duet dot entities, then we should be able to see, for example, all of our variables here. Okay. So we're getting our variables. Getting closer and closer. And we also have a warning for advanced bindings not implemented yet. And actually, we should probably continue there. So that way we don't accidentally set things that are like create a variable called canvas and then stuff like that. And also, I guess I can just have warnings here as well. So yeah, let's do that. Let's do, you know, I'll just do an error here. It'd probably be the whole binding, though. So basically now, if we do this, advanced binding's not implemented yet. Interesting that for some reason it didn't quite work. Oh, because this needs to do start. There we go. So now it gives an error here that this advanced warning is not implemented yet, or advanced bindings, initializing variables that are outside of this object script. And I'll do a similar thing for here. Let's get our events started as well. So that would be event type 4 blah blah blah. What are the children of that? So that has 2 children as well. Presumably they're an identifier and a thing. So like let condition equal or let's just do events. What did I change? 1629. Console log. Probably that parenthesis. Okay. So now we have a condition, and the condition should just be... I think a condition should probably not be that. Yeah, we should probably not have that equal to that. So that way I can, like, disambiguate better. That does mean that it's no longer set to blue when you do this, because now it's just an accessor. So yeah, I'll just do that here as well. Okay, so if we have that, let condition equal node children 0. Let so if I did like print hello, what would be the effect of that? Wait, does that not run the analysis? No, that should run the analysis. Oh, wait. It's hanging. That's why it's causing issues. So yeah, I think I never did this. So yeah, I think that causes some hangs. Let's just put that as a bug. Event with multiple effects causes a hang. But yeah, for now we don't need to worry about that. Because what I'll do is... I don't need that. Also, thank you for giving my full email address on stream. But that's fine. Cannot read properties of undefined reading class list. Log parse errors. Oh, I see. Wait, how on earth would I have a token that doesn't have... Hang on. If tokens dot... So if span, let's do this. If not tokens.i.span, continue. But let's actually do like a console error. So now at least it'll tell us. It didn't tell us anything. Weird. So that's something funky with the token thing. Oh, that's probably because we don't actually clear the errors? No, we do clear the errors. I don't get it. Yeah, that doesn't make any sense. But oh well. Okay. If cond type is not equal to duet parse node accessor, or cond type is, or no, con.children length is greater than 1. Error. Advanced conditions not implemented yet. And so that should mean that we can do that there. And so if I did like position greater than like 1, 1, it should have given me an issue here. Oh wait, it shouldn't have because I didn't reload it yet. Now it does it, because now I'm telling it advanced conditions aren't implemented. Okay, now we're getting closer to things here. Let name equal condition, no, tk texts, condition starts. Actually, wait, why do we even have, like, hang on. tk text index. Yeah, because I literally do that every single time. I don't need to. Just make the function do the thing that I want it to do automatically. Okay. Any other places? I don't think so. But okay, that means that now we should have entity dot events. So let's do if not name in entity events. Entity events name equals empty. And what we would have here is we would also need our sort of unencoded stuff, which I guess we could have it be event code or events. Because what I'm going to do is, before we do that, we just set that here. And so yeah, we'll only have our one event. And then events dot, we would need to add our unencoded code here. So to do insert pre-calculation, or pre-code. So basically we'd have like code as something in here. Oh wait, no, compute. Because basically everything would have an initial value and a update value. And if it has an initial value, that means it's guaranteed to be at least a instance variable. And that's determined by the existence of a semicolon. Because in the player, we initialize the canvas to canvas size divided by 2. Also, we can see that my my beautiful editor does not quite work well in Edge. Everything is a little bit different. But oh well. But okay, it's been almost 5 hours, so I'm going to use the bathroom. But I'm not going anywhere. I'll be back soon. Oh wait, for some reason my music stopped. Well, that tends to happen. Okay. So my next step now is not to do that. It is to analyze the value here. So what we would do is I would go to... let's see. Let's let val equal analyze expression. This would be ident dot... No. Value. So function analyze expression. Let's put this up here with these. So expression, so this would be an exp node. And so that means that now I can ignore this stuff. Don't quite need that right now. And basically what we're going to return here is we're going to return a all of the things that we need up here. So like type would be like type update storage undefined, compute undefined. And actually, this would just be code. So yeah, because basically, like, this is like our type info. So we not only have the actual data type, but we have all of the things that come from it. But okay, storage code. Oh yeah, I see. My, I keep forgetting. There's some, I guess it's just the text area has a wider font than my actual, than like the thing that I'm drawing here. So it gets progressively worse. I probably just need to put like a font on it. Okay, so when we analyze an expression, that means I actually need to do... Hang on, let's go back to analyze expression. Go here, press this. That didn't work because there's some issue with the tokens there. At like 60, oh yeah. Insert preprocessed code. I'll just ignore that for now. So yeah. Value is not defined because we did not have value. We had exp node. So now we have an accessor called player.create. Okay. That's fine to work with because that means switch exp node type. Accessor. pass. So what I'm going to do is, let's get the special case of, or let's let result equal this, return result. So yeah, a special case of creating nodes. Basically, what I need here is, I should actually just completely skip the period here. Alright, I guess that's inevitable though. Let A equal, How do I resolve a name? Oh wait, hang on. Let's just set this to, set that to 0. Accessor length I++. Let s equal accessor. No, let text equal. And actually, we don't even need that. We can just do plus equal 2. So yeah, this will be a resolve accessor. If accessor.length modulo 2 not equal to 0, then we actually do an error here because we know that an accessor has to have exactly an even number of things. Well, actually, it needs to have an odd number. Because basically, we know that it's either a name or it's name.name or name, well, basically name.other accessor. So an odd number. Ill-formatted accessor. Either extra or missing periods. And that would be, let's let the text equal, or yeah, return null. Let working text equal this. Let, nah, ignore that for now. So yeah, this will be a pk text soar start plus I. Let's do working text tilde equal text. Basically, what I'm trying to figure out is return null for now. Let's return null. So we're gonna do let name equal resolve accessor. Actually, I guess we just return here. And I'm going to have a default result. Oh. I'm thinking of the D programming language. That's where that exists. Cannot read properties of undefined reading length. Type accessor, that. So we should have an analyze expression here where we do this. And then type would equal val.type. Update would equal val update. Val.storage. Val.dependencies. And eventually I'd have to figure out how to do that. But okay. That means that for now, let's actually have this, so that's fine. Update, constant. You know, I prefer this term once. Oh, wait, no. So, was there any reason that I didn't do once? Okay, but can't read properties of undefined at resolve accessor. If accessor.length. Oh, because... Yeah. I'm just not calling it properly. Okay. So type accessor player.create. And that means that we should have... Okay, good. We have the name here, player create. And then let's do... If the name is greater... Or if the name is... Okay. If working text... Let's just call it AC. AC.AC.length -1 equals create. If AC.length equals 1, we will actually do an error here because create is reserved for making objects using name.create. And that would be AC, or this would be start length. Okay. Else, or actually, let's do like if it's not equal to 2. Otherwise, what we'll do is we are going to return, or let's let result equal default code. Because now what we do is result dot type equals type entity AC0. Result dot storage equals I guess it would just be up storage global result.code equals, this is now going to be VM call duet platform create C, and this would just be player, or no, AC0. This is gonna be like, let E type equal that. So actually, VM constant E type, VM constant 1, VM constant true 3. So yeah, now we know the type, we know the storage, we know everything about this. And we know its dependencies should be nothing, so that's actually going to be there. And storage should be global by default, actually. So we don't even need that. And we know if something updates once and it's global, it'll be constant. Okay. And actually that means that I have a better way of doing this, where I can just do like default code as type code. So like we would just return, yeah, because we can do that there. And then here we just return this with this. Ta-da! So now we have exactly one expression being properly done. And then otherwise what we need is we need the values from our VM. So like, Actually, wait. Hang on. I'm realizing, we need something slightly different here, actually, which is the expression node should not actually return code here until we know it's either not part of a function, because accessors are also like, if we did file.create and then in parentheses there, we would have a completely different thing from this. Well, no, actually I do need to do that. So we'd actually have, let C equal resolve accessor, and then we would do create, or like return accessor code C, like that. And so resolve accessor would just do that name stuff. We just have that. And then we do this and then have like function accessor code. So this would just get us a list of things here. So yeah, if the last object here is 1, we do that. And then we return default code. And otherwise, if it's ill-formatted, we do that. So now we can actually determine, like, if a function call will do all of this same logic, but then it'll do something completely different for the accessor. And now what I can do is, if platform, let's say if AC in duet.platform let v equal duet platform AC 0 file or for equal 1 AC I less than AC length I plus plus. Okay. If, and actually we should probably have the accessor here as well. See node AC. So that way we can do this. So basically what I'm doing now is, for example, let's go to game.duet. I'm going to remove that for now. And actually, I want the player code here as well. So like if we did file.loadSprite, or actually, no, if we did keyboard.write, we need to know that this exists here. So duet platform that. And then if not ACI in V, we would have error, no such field ACI. And the reason I need the actual accessor node is that now we're going to do AC node start plus I. Oh wait, no, times 2, 1. So hopefully what this means is that now if I go to here, if we did like not right, and then I compile and run, it should tell me, it doesn't tell me. So we don't need this here. We'll just do default code. Actually, we should have... Let's do that for now. Oh, wait. Is it working? Oh, right, it's not going to work because it's not doing anything with the top level yet. Yeah, I'd have to do something like this. And then it might figure it out. Result is not defined. That's getting a little bit closer to our accessor code. For now, I'll just do that. Oh yeah, and then we do, yeah, equals keyboard invalid. That should have told me... Yeah, so that's that. This invalid should not have been valid. Because yeah, when we do accessor, keyboard.invalid, If not AC... Oh, I see. And then what I need is actually v equals v ACI. Or we need that here, actually. Okay, so I equals 1, I equals that, that is that. Then we could do player that this, invalid, compile and run, doesn't exist. Oh wait, no. I'm basically just trying to make sure that this actually, like, happens. Object.analyze. Analyze all. Compile, compile, and run. 8.7. I see. What I'm actually going to do is variable's name equals whatever this is. Still not working. So yeah, if we have a creation, we do that. If the accessor 0 in duet platform I'm gonna at least try, like, create. So yeah, we at least get this. And then it does that. Okay, that's fine there. So now what I want to do is I want to figure out the actual system processing thing. So, like, if this first name is in the duet platform, that means that we need to get this thing, and then for each field after that, we like get this thing. And then what I'm going to do is if value, or let's say if get, or let's do like let code equal vault code, or let's let type equal, I know what to do, if not type in v. Not a valid value. And this would be, how do we join functions? So if I did like dot join, oh nice, okay. Not a valid value, ac dot join dot. Okay. So yeah, not a valid value. And then we'd return default code. So if get in v, we would then return default code v.type v dot, and then this would be code, so just be vm call v.get 0. Basically, there's two different ways that we can read values from this. Either there's a function called get on the field, or there's a field called value on it. Or v. We just call it that. And then else. This would be error bug. Invalid or misconfigured value. Let's call this no such property. And actually, we don't even need that. Well, actually we do. Because this is going to be AC join that again. Oh yeah. AC node start, AC node length. Oh wait, I put this in the wrong thing. That needs to be here. And we don't need to do it anymore. But okay, so we're getting closer to generating the accessor code. And then let's say else if AC length greater than 1, we're going to, for now, error advanced accessors not supported yet, or not implemented yet. Okay. So if we can have a creation, we can have a platform variable, we can have a length, or we can have like an invalid thing. Otherwise, we will have a let's do return default code with an undefined type, and then the actual code would be just vm.local, or actually I'm fine with that, because what I'll do as well is just have dependencies equals that. VM local, and then we'll also have AC0. So basically this means we're getting a local variable, and that should get a lot of things here. Why is this? Okay. Let's have this like that. Or like this. So now we know this depends on this variable. And actually that means that, let code equal, select code. Okay, but what we actually need here as well is, I know what we do. So, like, code dot, what do we need here? We need a whole bunch of stuff. Update equals, v dot update? No, I guess that's fine. And I mean, all of this should exist. And I think what I'll do is, for anything that doesn't have this update, we're going to do update, or once. So that means that anything that does not have any special parameters, which basically means update, is only on, yeah, things like canvas have an update, which actually, this should be on the, this here. And you know what, for now, it's just going to update once. A lot of this stuff is just going to update once. I think this would be frame. I mean, we can't actually depend on the type of that. Oh wait, we already have that there. Yeah, so frame, delta milliseconds, file, input. So this actually needs to be on here. Okay. So that means that now I have update this. Let's see what that gets me. Nothing so far. 1678. That's because I did not format this correctly, and I'm not sure how I didn't format it correctly. Return default code, which has an undefined type. And then it has vm.local AC0, AC0. There we are. Okay. So what I want to have is exp code, or no, accessor code. I want to make sure that all of these work properly. Which admittedly, there's probably only like one that actually exists, which is this one. So yeah, when we return from this, our code is going to be the actual like expression to create a player, which is good. And its type is an entity of type player, and it has an update of 0 and storage of 0 because it's a like pure function. It will not be updating every frame. Okay, and that's the only time right now that we have that. Okay, let's do function calls. Let's do numbers. Case duet dot parse node dot value list pass. Or let's yeah, let's just go through all these. Duet dot parse node function call. Case duet parse node number string parse node dot, what are the other, let's just look through all the parse nodes. Error script header binding event accessor. So we'd have number value list expression. Do we ever use expression? I should probably not have that there because that's kind of like ambiguous. Well, I'll leave it for the pros to figure out. Yeah, because I think the expression node should just be the node that's here. Like I don't get this. Oh wait, I do get it. Okay. Okay, I do get it. It's still confusing. But yeah, I do actually need a basically an expression node is a binary expression or unary expression. But okay, let's start with a number. So let's let working text equal nothing. And then for let t or I less than, hang on, we also need this here. Keep our things clean. Hopefully I just made it so that the numbers are valid JavaScript numbers. And then what I'm going to do is let n equal number working text return default code. Oh wait, no. Type dot number bm constant n. And we could have a very similar thing for our strings. So yeah, let working text equal nothing, and we would return default code. Okay, also, we'll just call it type real for now. Type string VM constant working text. So yeah, what I'm trying to figure out now is oh wait. Oh wait, no, okay, this is fine. For let I equal 0, I exp node dot length I plus plus. Let string equal pk or tokens node start plus I. So this time we actually need the string node. Because what it's going to be is duet token names string pk text exp node dot start plus I. Okay, hang on. Skip that for now. Anything that's been actually, like, printed here? I could have sworn... Oh, yeah, because function call still doesn't work. Okay, let's do that first. Or, you know what? What I'll do to start is learn how to do that. Okay, because now we have a quote, asset player, a quote. And so what we can actually do is I is 1 less than length minus 1, because basically we also have the quotes in here. Oh wait, no, and this is token dot type. So yeah, basically learning how to put all that in here. If token.type equals duet token string text. We basically don't need to do anything fancy. We just do working text plus equals token type. Else, if token.type equals duet.token.escape string text. Watch out, buddy. Now what we need to do is we need to switch on the actual token text. And for now, you know what? I'm going to be not terribly fancy. We're just going to have a T. And otherwise, it won't even support it. And then we just return our default text. And so we don't even need that. So now that won't do anything crazy. Okay, so we should be able to get numbers, and we should be able to get other things. And I think when we resolve an accessor, it should also tell us what the type of the thing is, because, we can get like const access type. Because we could have like platform local. Or actually, we can just return like a dictionary. And it would be like platform bool function bool. Because yeah, what we can do is oh, and then we can also have the type. And then probably like a reference if platform. And then also we should have the literal text. Yeah, I'm gonna, well, yeah, because we also have this here. If we do something special with the accessor, and I want that to be in here as well. So yeah, you know what we do need? Constant type equals function, or function create variable. Let's call var name func name constructor. So yeah, type access type local bool And then yeah, the type for return type. No, we don't need that. Yeah, because we don't know what the type would be unless it's actually a reference for a pointer. So yeah, what I'm actually going to do is match or switch AC dot type AC type dot var name You know what? I'll call it. That's fine. Oh, I see. There we go. Got a sense of humor on it. And then break. Actually, what I'm going to do here is console or error. Function references aren't valid. Implement or are not yet implemented. And that would be AC node start, AC node length. So basically, the access, this resolve accessor will determine if it's a function, variable, or constructor. And then what we can do is we can call that constructor on the thing here, and it'll have like no arguments by default. Okay, case. Thank you, Godot. Type dot constructor. CTOR. Let's call it that instead. So if AC length is greater than 2, otherwise we will let eType equal that, and we will return. And actually, we should know this, for example, if the length is greater than 2. Yeah, we don't need the string, so we're going to return type AC type CTOR local false ref no actually, now that we know that a function name is here, we can actually do this. Oh wait, no, we can't. I was about to say we could have the function called here with no arguments, but for creating a thing, you actually do need the argument, so there's still a special case there. I mean, I can do that actually, though. We just return, So yeah, this is a function with no arguments. Either a platform or standard variable or local variable. If AC local error, local functions not yet implemented. Okay, what we would do here is we would actually return default code AC ref return, I think is what it is. We need to go way up here. Yeah, we would need this return. So we need to make sure that all of these references have a return value, which actually means that I should probably do that for my off-gen or gen bin-gen. So this now needs type, or like ret type. Say a type function, return, ret type, args, okay. Okay. So yeah, ungen, bin-gen. So now we can actually get our binary types here. But that means that for bingen here, we'd have to do a lot of, well, it wouldn't be that bad. Basically just do type real. And actually, we only need that because for all of these, the return type and the argument types are all the same. Oh. Yeah, we don't even need that. So, okay. That means that now we have this, and we could do like type function return this args would be real. And here we just have an array of type real. Did I ever use ugen or ungen? I don't think I did. But okay, type Then our args are an array of 3 of those. There we go. Oof, okay. So now this actually, well, when we return a function, yeah, that's fair. It's a weird generic function thing. But okay, now we go back down to here. Now it should be able to tell when we have a function, when we have a thing, when we have a that. So I'm going to go back to resolving the accessors. So like if the accessor is in here, what I'm actually going to do, I guess I'll just figure out how all of this stuff works together. And this shouldn't happen, but we'll just return default code. Thank you, Godot. Or whatever the hell this thing is. You know what? Let's even just... Well, I don't know. I don't care. This code's gonna look horrible. Wait, and this also needs to be 0, 1, 2. Okay. So yeah, create is reserved for making names with that. I'll say that's fair. Create is... So we'd return local as false, reference is null, text is AC. Okay. So that means we'd have a lot of this stuff here. So the E type is now going to be AC text 0. And I think nothing else needs to be done here. Wait, no, that still needs to be whatever it was before. 0. Yeah, 0 needs to be here. Okay. Basically, a constructor creates things. Like that. And then otherwise, what we're going to do, call ac.ref 0. So like before, or like I was saying, this reference here is not fully processed yet because it doesn't know how often the function needs to be called, or like if it's called on a list of values or just a single value. Well, actually, I think if we have a function with no arguments, the assumption should be that it's a scalar. And then what I'm going to have here is like, else if that, else if length is greater than 1, else what we're going to return here is return type AC type dot var name local true. And honestly, we don't need like all of this other stuff here. We just need the text. Because now what we do for our var name as before, we just get our local. We don't know the type of it yet, but we do that. And this will be text 0. And I think to do figure out nested identifiers. Actually, and this is if AC local. Else if get in AC ref. So now we're actually figuring out this stuff. Because we don't need any of that in here, we can actually put that all in here. So this would be v.ref. Actually, this is AC. Oh. Okay. Okay, so this would get us variables of all shapes and sizes. And now I need to figure out exactly how that would work here. Because we'd actually have the type. Code equals. Actually, I'm just gonna, yeah, let code equal default code AC ref type. And I'll just assume that it works, because if we got a reference, well, actually, we can just check that here. So yeah, if not type AC.text, so not a valid platform variable. And yeah, otherwise we return all of our code here. And I'll just return that right there. And let's call that a compiler bug, if there's some other issue here with get and value and stuff like that. But okay, we don't even need break. So that means we now have variable names correct. And we should have function names correct because all they do is they get their return type from the default code and they are called with nothing. Though we should probably make sure that the actual thing, so if not ac.ref.args.length equals 0. All right, let's simplify this a bit. Error. Function called without arguments, but it expects. You know, every single time I write this, I should probably have figured out that I should just like assign a node to the bug. But oh well. Because in the rare case where I need to do something like this, I could just have start and length as like this. You know, I'm going to change that. Yeah, look at how many places I need that. So I'm going to have just a node here. Yeah, look at this. Duplicate variable declaration. You know, I don't even need that. I can just have this identifier. Because the declaration should just be the accessor. Yeah, literally like 99% of the use cases of this, I just get the node that I'm having issues with. And in the other cases, I can just write the syntax out to explicitly specify a start and end. Oh wait, hang on. 1 ACI minus 1. And so this should always exist. Yeah, that should always exist. Okay. How much of this stuff actually works? I mean, I guess I won't really know until I actually have our other code here. But okay, so we can like convert local variables. We don't know the actual type of it yet. That's fine. We can convert our system variables though perfectly fine, because we get all of their types from here. Oh wait, yeah, that's fine. And actually, the reason we know... So yeah, let's go now to here. So we don't need this v.type, so we're going to do... Oh, wait. This we actually do need here. As that. code.update equals this, return code. And variables don't have storage, so that's fine. Or functions don't have storage or variables that are on the platform. Okay. All of that to say, what I need now is when we resolve the accessor, I actually need to figure out if it's a variable name or a function name. And that would be if or let v.type equal type function. Let AC type equal type or AC type.var name. Let's say that, and then we're going to return type AC type text AC local false. Anything else that I need here? Oh, we need the reference v. So for our platform variables, we actually determine if it's a function by, well, if it has the type of a function or if it has the type of a not function. And then we set the text, we set local, we set that. So I hope that that works. Well, not quite. Missing initializer in const. Probably because I didn't set an equal sign there. Because I keep thinking of enums. Argtype is not... Oh, right. I've done a lot of stuff. Okay. So we have analyzing an expression. We can get the accessor and the accessor code. We now need, for example, a function call, which would be just break. Actually, return. Well, we'd return something. So let's do like let fn equal code nothing. Well, actually, I know what to do. For hang on. How do we do function calls? Function calls have two children. The first child is a accessor, the second child is a value list. So let name equal exp node.children 0. Let value equal exp node dot value? No. 1. This is going to be args. Let code equal nothing, because what we're going to do is for let a of args, we are going to basically get each of these types here. So args dot or code equals code concat oh wait, no, and this actually needs to be dot children. let's get an accessor in here. So we'll do resolve accessor. And also, since we're in here, if an accessor isn't an accessor, not equal to exp node dot, parse node accessor. Basically, I'm calling this now without actually checking if it's an accessor, because sometimes it's just supposed to be. So we'll just do error bug. This was supposed to be an accessor. And now we return, you know what, let's return null, because if the code's gonna go wrong, it might as well really go wrong. And what we can do then is function call. So if the name dot type is not equal to an AC node, or AC type dot function name, console, or no, error, expected or tried to call a variable like a function. And that would be exp node children 1. Or no, children 0. Okay. And so let code equal, we'd actually have like a let, oh wait, no. We don't care what the types of the arguments are here. Because what we'd actually want is to get the argument types from somewhere else. So if not name, or if name dot local error, local functions not implemented yet. Turn. And this one, exp node, just the whole node. Okay. So then we get the args. So let ref equal exp dot node. No, name ref. So let code equal exp a. So we're basically going to analyze each expression in the arguments, and then if we actually need this to be I in, or let I equal 0, I less than args children length, I plus plus, a equal args I, because I actually need to also check if reference dot args I is not equal to a dot type. We would error right here and say that expected an argument of type, but received, and this would be, ooh, I don't actually have type names. Let's put that, wait, where do we have our parse node names? Where do I actually set these? Because, for let n in let parse node. Okay. I did not realize that it was all the way down here. Type. So basically now we're going to have a type names. Okay. So if our reference does not take an argument of this type, we can just do expected an argument of type names. I'm going to do let expected type equal this. Because I can't be bothered to do that multiple times. Okay, and that would be specifically the argument itself. But we can ignore that for the sake of this. Because then what we'll do is we will code equals, or no, this is going to be arg code. So our code is code concatenated with the arg code. And then what we do is finally, actually we don't even need that. We're going to do return ref.return return update as ref.update or update once. Code is code concat. We'll have one final instruction, which is the actual call. And that would be reference. And then arg's length. No, children. Okay, so that's getting us much closer to actually being able to parse some things. And there's no... I guess there is an instance where we have a value list, and that is when we actually have an array. Okay, parse node is not defined because I did not set that properly. 1635. This code is going to be... This is, I'm proud to say, some of the worst code I've ever written. You cannot read properties of undefined reading type object up printable tree. And that is because when we go to 1757... How would that happen? Because we're just reading the string type. Oh wait, no, we're not reading the string type. You know what, let's just do if we get up to this point, if type of exp node is not equal to object or not type in exp node console.error, not a valid expression. The node return default code. Okay. Oh wait, no. We need to do error here. Oh wait, no. We do need to have that. That's not The whole thing is that. Okay. So not a valid expression undefined. I see. If args.type is not equal to duet.parsenode.values list error list of arguments for the function. So I think maybe I'm just assuming something wrong. So if we go to player, expected a list of arguments for the function exp node at token 9. Wait. What? This has a span, though. Okay, well, I'll ignore that. But parsing error. Expected a list of arguments for the function at token 9, and then we don't have our... And I'm just going to call it an error. Because now we actually have several types of errors that go through this exact same thing. Okay, function at token. So let's do list of arguments. So for the function, let's do ref.text.join not joint. So can I read properties of undefined reading join? Oh, this should be name.text. So file.loadSprite. So surprising issue is that well, then what's the function call here? So children, accessor, file.loadSprite. Oh, because it's a value list, not a values list. Okay, a little bit better. 1816 we're calling an issue. For let I equal 0, I is less than args.children.length, because this is children. Oh, wait, no. That's fine. Okay, so let's do or not name ref. Not implemented yet. This would be name text join. Cannot read properties of undefined, reading 0, so that is at our object analyze. And that is at analyze expression 1816. I I guess let's just log a reference here. Or like, let's do name dot text. So yeah, file load sprite. Type is type.function. Hang on. Do we not have a type? Oh, I bet it's not called type.function. I bet that's perfectly fine. Okay, I'm surprised that it worked, but I think that's actually because it was, okay. But that means that we have a type, we have update, we have one argument, which is a type there. Then we return an image. And so, oh wait. It's called args now. Silly me. Okay, I got a little closer. So if expression type is not equal to a.type, analyze expression a. We should always return a default code. Sol.error not supported. Let's just call this a printable tree. So this should never return. Oh, I see. Oh, wait, hang on. Not a valid expression, undefined. So when we go to 1816, okay. If a, let's just console log a here. Oh, wait. Easy. I love dynamically typed languages. Where you can just, where half the bugs are just object.field that doesn't exist. Okay, so now we're getting a little closer. Because we're getting the string here, and then we're getting a number, then we're getting a value list. And so I think that means that now the issue is at 1529. Duet.parseNode tree.type. And that's because if we go back to 1834, not supported, expression that. Okay, well that's fair. And so now what I'm going to do is let type equal undefined. Oh wait, hang on. And that's redundant. We can just do this. Because basically, if it's not an object and there's no type of this, then it's definitely not valid. And that confuses me here. Because that means that I think this here is not being set properly to something. Variables, name, expression, value. Oh, because are we not even returning something here? No, wait, no. That should be fine. Huh. Okay, I'm gonna ignore that for now. I'm just gonna figure out like the value list and things like that. Case duet parse node. Function call value list. Let's do let type here, and then we'll have a function rectify type. Wait, no. I have a good idea. Type equals -1. So let or for let a of value or exp node dot children code, or no, type array. I guess this would just be type. Okay. So for each object in our list here, what we're going to do is type equals oh wait, no. Code or let arg code equal analyze expression a. If type greater than or equal to 0 and code type is not equal to type, we will do an error, which is assumed list was of type this, but value is of type that. And that's going to be at A. Because we'd have type, or type names, type, and then type names A.type. Basically, the list of values has to have the same type throughout it. And then what we'll do is code equals code concat arg code code. That also means that the list here, our variable needs to have the maximum of all of its values. Hang on, that's going to be, how would I do that? Update equal update dot once let storage equals storage.global, and then update equals max. Actually, do we have a math.max? Okay, good. Arg code update, or arg code update, update. And then the same thing for storage. And then I think we wouldn't even bother with the default code, because nothing here is going to be default. Yeah, because we get a type of the list of type. And also type equals arg code type. We add our code. Update storage. Storage. And this is now going to be elem type, actually. There we are. A list of those. So yeah, we have to type update storage. And then code concat. Our code is code concatenated with our last instructions would be VM array with a length of exp node children length. Okay, so the last thing I need to do is figure out case duet parse node expression, where basically this is now binary expressions. It is funny that I had a dot here by accident, and then because, because duet.parsenode dot default is still a value that can be valid here. Okay, so what is our actual tree? Oh, I see. Because we need f, or file? What is our file called? It's somewhere up here. Yeah. Classic mistake. Call a function with too many variables. But okay. Now we're getting closer. So we should probably also have value equals whatever it equals. Analyze expression. Let's print this. Name equals variables name. Okay. It's a type of an array of undefined. A lot of undefined stuff here. That's good. That's good. Oh, right, because we need to... Right. That's completely fair, actually. Because a lot of things have undefined types because we don't know the types. So, for example, movement is an array of... Well, actually, I have no idea what it's an array of, and I don't know why these are undefined. Because a value list Because, yeah, this type shouldn't be undefined. And this code shouldn't be undefined either. Because basically what's happening here is the code is undefined, and then we do 4 and 2. So I'm just going to do console log arg code. Oh, I know exactly why that's happening. Because the value list is bad. Because it's expressions. Okay, let op equal exp no.children 1 or 0. If let's do if exp no.length is equal to 2, unary code. Else if exp no.children.length equal to 3, binary operator. Else error operators only, or let's say compiler bug, only work with 1 or 2 values. So here we really should have the value of our types, basically. I'm going to go back to here. So exp node, no, well, yeah, that's exactly where I want to be. Basically, I'm just going to figure out what the heck I do here. So yeah, this operator should equal if op.type is not equal to duet parse node.operator error compiler bug expected and operator. Okay, that's good. And then our children are 2. And now what I need to figure out is how I'm going to compute what these are. Basically, actually, let's just do if exp children length greater than I actually need this to be or for let I equal 0, or let arg code equal nothing? No, let code equal this, let type equal -1. Basically, we need to figure out how to rectify the types of values here. So this is going to be 1. I is less than exp node children length I plus plus. Okay, let a equal I. Let arg code equal exp node dot What I'll have here is I'm just going to have exp, or I'm going to have the VM call, but it's going to be just the text of the node, or maybe the token. What should it be? I think it'll be the text, so that way it'll be much easier to figure it out later. But okay, exp node dot, no, this would be analyze expression. And actually, I may, instead of doing concatenations here, I may want to push here, so that way I can still get... Yeah, I'm going to push here. Basically, the reason I'm doing this is because I want to be able to get the first argument of each thing without having to, like, re-parse the whole thing. So I'm just going to flatten these at the end. Okay. Code.push. So yeah, this way it's kind of like a Lisp almost, instead of like a bytecode. But okay, so anywhere else we do code concat? No, okay. But yeah, what I'm going to do is type equals... For now, let's just do code push arg code, and then code push fn. This should be VM call, and then it should be the actual token text of our given node, which would be opt start. And then exp node children length -1. Return. And actually here as well we'd have all of our like let update equal update dot once, let storage equal storage dot global. And I think we would need the same thing for function calls as well. Like where we actually get like all of our code here like this. And then each time we do this, we do like code push that, update equals that, that equals that. And I'm too lazy to actually make that all consistent, so I'll just not do that. And our type would just be type for now. Let's just make this undefined. Well, yeah, for now it's just going to be that. So like, type is just going to be type or a dot, or code type. I'll figure it out later. To do properly figure out what we can. Because basically, the type of an operator depends on the type of the variables. So we know that there are no... What am I trying to say? Basically, we have no idea what the expression is. We have no idea what this type is until we actually, like, set it somewhere else. But okay. Hi, welcome to the stream. Oh, EXP is not defined because I'm using EXP node. And that's at 1862. I am making a programming language, so 1872. Let's go to the future. A. I'm probably at the max of my brain. Yeah. Yeah, and I was gonna make it in WebAssembly, but I have like 3 more days on this game jam. Probably, well, closer to 2 more days now, because this day is just about done. But yeah, because all of the performance gains of like, it's a highly like batch heavy interpreter where it's like all the code is structured around like turning operations on a bunch of little things into one big operation on a list of things. But those performance gains are completely hypothetical. Interesting. What is AC node? Where am I doing that? Hang on, what is this? 1678. I'm doing more advanced stuff now. Accessor. Ah, I see. Yeah, I'm not a fan of dynamic typing, but it is really nice to be able to just reload the code, or change the code and reload it. But okay, 1708. AC ref. Yeah, for JavaScript. So yeah, that'd be a reason to switch to Idris, because I know that it has the dependent types. Or is that... I think that's Idris. But okay, advanced accessors not implemented yet. That's a-okay. Let's go to my... Where's game.duet? So, okay, I see. Advanced accessors not implemented yet, but these should be system accessors. And also another nice thing about JavaScript is the fact that I can, like, I have this little editor that I made where I can just tie directly, like, the parsing results into it. Because otherwise I'd have to figure out how to interface with some other editor via some other language. But okay. So for some reason, our advanced accessors not implemented yet. Even though we should have AC0 in duet.platform. Oh, we don't have it because it's called input now. Let's Shift Control R. Huh? Why is this not... This should be loaded from... Okay. So I'm like close to actually having expressions that are parsed. So now it actually analyzes all the expressions. And then the big thing left is we need dependencies. So I think default code. Resolve accessor. I guess we don't need that here. We need that in accessor code. So anytime an accessor is local... Oh, okay, I already do that. Basically, we need the graph of variables that are dependent on each other, like the fact that the player's position is dependent on their movement. Because that's going to be used to determine what variables have to be updated when. Which means that once we have... I'm going to go up to update. So I'm going to have like const, or let update names equal nothing. Let storage names equal nothing. Let VM names. And I'll basically do what I did for all of my other things, which is basically just to be able to, like, read a type. Update? Oh, wait. Update. Storage. VM. Basically to have the names of values in an enum. Because now what I want is I want the ability to print out my expression tree, because I've done like the first stage of analyzing. And that means I don't need to print here. Creating instances of that, promise fulfilled, creating that, loading that, okay. Oh man. I really went to town on this analysis now that I figured out what it actually is supposed to look like. Okay. So we resolve that accessor code. We have analyzing the expression, and now what I need is basically like a second phase of analysis. So let's go to for name, or let var in variables. Let's have a function printable exp, or like a print var. Okay, so I want to basically have some sort of thing that I can print when we compile. Because every variable will have their type, update, storage, code. And also... Oh wait, that's fine for now. Because basically, each of these codes will be... Okay. Val what is this? Type names val update names dot update storage names val dot storage, and actually we should have like a val dot type and this, because basically these can be undefined if they're not yet determined. And then for the code, it's going to be val.code.map. This would be each line of code. We would do a VM names line 0 dot concat. And I'll just do the rest of the line. So basically it'll have the instruction name, but then the byte code, and then the rest of it. Actually, we can do line 0 equals VM name line 0 no wait, that's gonna be, I don't know if that'll like affect the lines. Okay, I'll just do that. Okay. So here's what we have now. It's not quite correct. Why is the code like this? Because first of all, not all of these should be undefined, because like some of these are like the number 0 is an instruction. But okay, storage. Oh wait, no. Wait. No, yeah. I think these both are never undefined. But the type can be undefined. Okay, that's a little bit better. So basically, it assumes that my player is a global that's going to be updated once. It assumes that for the sprite as well, except for the fact that storage should not be undefined there. So for load sprite, oh, I see, storage. Wait, but hang on. Then why would a function call? I guess it's because each variable would have that. So let's go to string. Parse node string. Okay, so we should have... Yeah, this should be correct. Basically, we return a string. And it's going to be a constant with working text. Let's go to sprite. What is the code here? Oh, okay, now it's looking right. I think it's just for some things. I know what it is. It should do, line. Basically... if array is array line, then we do this. I know what to do. Let's do readable code. So if array is array code 0. So basically, if this code is a list of lists, we will do readable code equals code map. I should have just kept that. Ah, well. Line into VM names. Line 0 concat line. Hang on. How do we do like a dot pop remove delete A0 A. I see. That's not quite what I want. Includes index of map pop push slice. Okay, wait, I could do slice. 1. Okay. Okay, else. Okay. A little bit simpler. We have a function to get a readable line, which is basically just get the name of the first instruction and then add the rest of the arguments to it. Okay. Almost. Almost. Oh, right. So yeah, for example, our player is basically, we get a constant, which is called player. We get, oh, I see. CTOR. When we do a constructor, in order to properly get all of this stuff, we need to actually have each of these instructions separated into its own list. And then we can flatten it once we actually get it properly in the byte code. Oh yeah, that actually means that I need hopefully trailing commas are allowed. They look like they are. Advanced accessors aren't implemented yet. That's A-okay by me. Okay, so now it should make a little bit more sense. We have a constant, which is just the string, constant 1, constant true, and then we're calling a function, and that function is this thing here, which is a whole bunch of stuff. That's the actual constructor. Okay, and we don't know the type of that, which is strange, because we should. Oh, I see. Because sometimes it's not an entity. Array. Oh, wait, no. Printable code? Printable var. So let's do let readable type equal undefined if val.type we'll actually have a very similar thing here where the first value we'll actually just do well, almost the same thing, except for the fact that this needs to be type names. Else. There we are. And then that is now readable type. Val type in type names. There we go. There we go. Okay. So now we're getting a few more things. So for example, we know that our speed is a real value. It's updated once, it's globally stored, and its code is just a constant 10. Our movement is a global. Its type is an array, which should not be undefined because we just get... Oh, wait, yeah, it is undefined. That's fine. Because we have an expression here. Yeah, because our code is actually... yeah, we get an array of value 2. And then here, what we're actually doing is we don't know what these values are, and then we... Well, having the undefineds here is kind of an issue. Because these are supposed to be... Oh, I see. Okay. So now let's look at movement again. Because movement is an array of value 2. Let's zoom in a little bit. Yeah, I don't need this so tiny. Yeah. Because it's a vector of left and right. Or like left, right, plus up and down. But we don't know the type yet because we have to resolve all of the types of the variables in an expression before we do this. Which actually, we could figure that out pretty quick. Because, like, we know, for example, that this value is a an array here. But also, good, it knows that it needs to update every frame, but it's global. And then position. Oh, right, position isn't quite done yet. Because we don't have the code here quite correct. Yeah. This position isn't quite right. Let's go to binding. So we need to actually have duet.printable node, file node. Readable node? Printable tree, that's what it's called. Binding. Yes, okay. It's very simple, actually, because all I need to do is I can tell which one it is based on whether or not it has 3 children or 2. And that means, what does that mean? Let's just get... So variables.name equals this. What is variables.name supposed to be exactly? I'm going to do let or if binding two variables. That means variables name storage equals instance. And then variables name dot let's see, let e2 equal, all right, hang on, I'm gonna do let value 1 equal that. So let's call this actually the expression 1. So we don't even need any of this stuff here with like advanced binding and stuff like that. And the name and that. exp1 is that. Value 1 is that. Okay. So if we have an initialization and an update, or and an integration. That's what I call it. Basically, this is designed specifically for values which depend on themselves and will update every frame, but need some initial value. Which is basically just here, where we put the player at the center of the canvas, and then we have a new position that's clamped like that. So let value 2 equals analyze expression exp2. If node children length is, well, actually no. If it's greater than 3, console dot, no, error, compiler bug, more than 2 values for a binding. And that would just be the whole node, I guess, is broken. But okay, so that means that this variable should have, I guess we just have compute. And so yeah, I think we just have like init and like other, or init and update or something like that. And we won't know for sure until later which one is which. Okay, I need to figure out where all my variables are. I'm not actually sure. I've completely lost it. Okay, compiler bug here. Okay. Basically, this means that, variables.name storage is guaranteed to be an instance variable, but we'd have variables name dot integrate equals value 1. Probably code. I guess I'll just say that. Variables name dot init. No. There we are. Else variables name equals value 1. I'm going to set this here as that. So expected 1 or 2 values in binding. Okay. So I think what I might do is actually just set this. I'll set this equal to this, but then I'll set this binding here. No, okay, I see. I see what I want to do. We'll do that. We'll set this. We'll set this. Let's see if that makes any sense. Reference error instance is not defined. Oh wait, is it yeah, it's because this is supposed to be update instance. exp2 is not defined, and that's because I did not get exp2, because that's just going to be node children 2. Don't even need this. We just put that there. Okay, so now if we go to the player, if we go player position, we have our type, we have our we should have integrate here. Oh wait, but it's not going to be in there because if we have, hang on, r equals that, and then if r dot, or if integrate in val r dot integrate equals basically just another printable var, r dot or val rate r. So now basically I don't really need that right now. But what I'm going to do is I'm going to go to readable var, or printable var, I guess. And then I'm going to go to integrate, because I think this is the issue. So if we go to val, and our integration should have undefined, no dependencies, no storage, no type, no update. Which is concerning because that was supposed to have that. Update. So is that func call? Is that because function calls are not valid right now? Because yeah, the code was supposed to be this. Integrate equals analyze expression. Let's go to 1929. Probably a good year. No, it wasn't. It was a terrible year. That's when the Depression happened. But okay, so I need to figure out why this is not right. We don't need that. Wait. Integration is happening before we do this stuff. Okay, so what is our expression? It'll be kind of tricky to figure that out. Is there a way to get an arbitrary expression in here? So if I did like the console... application, let's see... Breakpoints, watch, call stack. I guess I'll just see what this does. So we got a function call. We got our name, which is just clamp. If name.type not equal to... Ah, okay. Because we need some overrides here. Okay. And that's because that's happening. And so now if we go forward... Okay, I was just not seeing that happening. Oh, because that happens first. And I'm going to say this should be just nothing by default. That'd make more sense, so that way hopefully this doesn't crash every time. Okay, there we go. So now it actually has a better thing, which is just that. And also, I'm going to ignore token is bad. Because that seems to be some weird bug that I don't particularly care about, because it's very easy to avoid. But okay. That's a little bit better. But yeah, now we can see the actual issues that it's identifying. Some of these are correct, which is that Edge very, very stubbornly refuses to reload this file, even though it's been correct for like 2 hours now. But yeah, this function clamp is actually an override, because it's a type-dependent function. So I'll do basically const, or no, overloads. Clamp would be vector. So this would be duet.platform. Oh wait, no. I can't get references to things until I'd have to do like a opv and then scalar op-s. Okay. So what I'd actually do here is, if so when we resolve an accessor, we actually need to first check if it's in the overloads. So that would be if AC0 is in duet platform. Actually, let's do else if AC0, or let's do AC.length equal 1. I guess. And, I don't know what to call this. This would be overload. Platform function that must be determined at the next phase of analysis. Okay, so basically, yeah, for now I'm just going to do length is equal to 1 and AC0 in duet dot overloads. Return type AC dot overload text AC. And basically, if it's an overload, what we would do is AC type dot function name. Let's do case AC type overload. Guess we don't need that yet. Actually, what I'll do is like arg count. Or, hang on. I have a good idea. We need type dot... Yeah, we'll get our types from up here. Well... I know what the overloads will be. The overloads will always work only on either vectors or on scalars. And then we'll have like our base type, which will just be like type dot real count 3. Let's call it that. So this way we can get the overloads for this like that. So yeah, if it's there, we'll do text equals that, ref equals AC. Zero. Okay, so basically that is only applicable to function calls. So if the type name actually, let's see, and name dot type is not equal to AC type dot overload. If it is local or not ref, how do we make sure that that's not true? Oh, wait. That's in here. Okay. So now we actually need let's do name.type equal AC type.func name. It'll be that. Otherwise, it'll be ref.base type. And actually, that means we can trivially figure out, like, let arg, or like expected length equal this again. Basically, this dot length or reference dot arg count. And basically, for now, I'm just going to assume that all overload functions will have, you know, take all variables of the same type, because I can't be bothered to make anything more complicated. And then if dot children dot length is not equal to expected length, we'll just have an error here of function name, no, dot text 0. I guess name dot text dot join. Function block, expected name of that, but retrieve that. So function this expects exp length arguments, but was given args children length instead. And that means that we can also get what would this be? We would get the full list. I guess it'd just be args. So that's where the error is. AC is not defined, and that is at 1672. What happened that year? AC type.overload. Did we get any further? Let's see if we can get some stuff. That's not quite right. Oh, right. Yeah, look at that. Now it actually can determine, for example, that function file load spread expects one argument but was given two instead. And I could do even further. I could do like one here, and then it tells me again. No, it expected a type of string. If I received a... If I received a.type. Wait, what? Arg code. That's what I need. Expected argument of type real, but received argument of undefined at type blah. And that is because an overload can actually take anything of those types. And also, if they are undefined, so if arg code.type and I know what to do. This should only happen if AC type... Oh, wait. Yeah. If AC name type blah equals that, that means that expected type is equal to name ref type, no, args I. This is the type of the argument that is expected for this function, and if we have a type but it's not equal to our expected type, we'll have an error here. Okay, So now we're getting a little bit closer, because now clamp should do that. Okay. So now we can go a little bit more. Because you can see, for example, our position now has a call to, division at first. But then it has an integration. And that has values of, for example, this here. Okay. This reference. It actually needs so overload. So we actually need a name here of clamp. So that way we can disambiguate what this would be. Let's just call it overload. So basically, once we're doing like our second phase of analysis, which is like disambiguating the type and stuff, we will then figure out which overload to use, and we'll need this information to make it clear that it's not one of these existing function references. Okay. So yeah, we have our code and we have our integrate. And this means that code is now our initial code. And so that should hopefully, yeah, we have update once there, integrate that. So our integrate should also probably, that needs to figure out where it's updating. So we have 2 plus, why do we have 2 plus 2 here? Wait, I don't understand what I'm looking at. Hang on, okay. Our code is undefined array of 3 of array of 3. Undefined array of 2 of array of 2. There should not be any arrays here, I don't think. Well, actually... Well, that should be okay. Huh. I don't understand what these mean. But okay. Yeah, we're not quite getting what I need here. Oh, wait, no. We are kind of. Okay, yeah. It's just that these are nested. If array. Hang on. Readable code. So readable line. So we actually need readable code to do this each time. So if I'm going to call this our code. Because basically, we need to recursively check if anything's an array. Because it seems like the code is kind of falling apart on us. Wait, but no, that shouldn't be true at all. Oh wait, yes it could be. Because lists of values will have their code as lists of values. And that explains why this is a list, and this is a list. I mean, it doesn't explain why this is a 4 and a 2. Or, oh no, it does. Okay, yeah, never mind. Because that's an instruction. So this is like 2 values. A constant of 0, I'm assuming. Okay. So, readable code. Basically, if the first argument is a line, we will return this. Otherwise, we will return I guess we just return that instead. Okay, maybe that'll work? No. Oh, because we need to do, for... Wait, that doesn't make any sense. Oh, it does make sense because this is called line. And we don't need that at all. So we were infinitely recursing. Okay. So now if we go to the position, it should be a little bit easier. It's not quite easier. Oh, wait, no. Wait, what? Oh. Okay. Now if we integrate, our code should be an array, so we have a local of position, and then we have local movement times that. So yeah, now what's happening is each time we have an argument, it's in this order. So we'd eventually flatten all of these. But this is kind of useful. Because now we know clearly, for example, that this is this local plus whatever's in here. Okay, that was the thing. This is the most complicated function here. And so yeah, very valuable to figure that out. And now the question is, why does this say it only updates once if... Oh, because this... Oh, because this doesn't know that movement yet. This doesn't... Okay. It's because this doesn't know anything about movement yet. So yeah, that's why, for example, it doesn't know its storage, it doesn't know its type, it doesn't know its update. Oh wait, no, it should know its storage. Yeah, because the position is guaranteed. Storage equals... it should be guaranteed an instance. So integrate update dot... Oh, because this should be storage instance. That's why that was undefined. So yeah, now storage is instance. Okay. I think that is about the most that I am able to figure this out today. Well... Yeah, I should probably stop now. I've written like 1,000 lines of code or whatever I've written today. Well... Only a few hundred. Not that bad. This'll be fun for somebody to eventually figure out how the hell it works. Add dot. So now git commit m first phase of analysis. So basically the next phase would be getting all of the dependencies between variables together. That should be fun. Figuring out the types of all the values based on their local variables and like getting the overloaded functions, getting operators, and then figuring out where to put each of the compute slots. And so they shouldn't be too much work, I think, left. But then I actually have to make a game, so be a lot of work tomorrow. I should get up early or something. But okay. I am going to go now. Have a good night.